Recording, go.
All right. Well, excellent. Welcome back, everybody, to day 2 of Virtual Bootcamp. And I think we're kicking off this morning with a presenter that you met yesterday, Jen Weld from Penn State, who is going to be starting our day talking about cropland conservation.
Good morning, everyone. Thank you, Jen. Let me share my screen and we'll get started. Okay, so everyone should be seeing a title slide, Introduction to Cropland Conservation.
Looks good, Jen.
And you have audio for me?
Yep, we hear you.
Perfect. Okay, well, it's great to be back with everyone this morning. I'd like to thank Tyson Myers with NRCS for preparing the information that we'll be discussing today. For those of you who may not have met me yesterday, my name is Jennifer Weld. I work with Penn State in the Department of Ecosystem Science and Management. I'm the director of the PA One Stop Farm Planning System, and I'm here to discuss the introduction to cropland conservation with everyone. So we're going to be looking at some primary cropland resource concerns and some practices that can be used to address those concerns. So the concerns that we're going to be looking at today, there's 3 primary concerns we're going to look at. Concerns around soil health, gully erosion, and in a moment we'll look at sheet and rill erosion. So cropland resource concerns with soil health really kind of revolve around depletion of organic matter, as well as compaction. When you start to deplete organic matter and kind of create an imbalance where there's not enough organic matter, and you start to compact the soil where you don't have a balance we talked about yesterday between, the air and the water and the pore space, you start to have soil aggregate instability. And basically what that results in is you have a soil that doesn't have a strong structure, right? Soils have texture and soils have structure, and they need structure in order for roots to be able to penetrate down through the soil, in order for microorganisms and macroorganisms to exist in the soil to maintain a healthy soil and a balanced soil. And also, as we have aggregate instability, we also lose the habitat and the food that's necessary to feed the microorganisms, specifically fungi. They are much more fragile than bacteria, and they're more susceptible to a degradation of soil health and depletion of soil organic matter. So as we think about some of the practices and how we're going to balance those, soil health is a concern, a resource concern. We also have concerns with different types of erosion, and there are different types of erosion. We've discussed gully erosion yesterday. There's an image of that right here in the bottom right-hand corner. And gully erosion is different than sheet and rill erosion. It's usually forms, this is classic gully erosion. It's forming kind of a, looks like a ditch running right through the field. You're going to see vertical erosion. You'll see lateral erosion as that gully opens up, but you also see something called upward erosion, where you start to see the gully extend not necessarily downslope, but also upslope as the gully becomes larger and larger and more present. These types of gullies cannot be eliminated with standard tillage practices. They require generally an intervention in order to fill them and in order to make that part of the field productive again, and also to address how the water has changed, how the water is flowing differently because of the gully. So that's gully erosion. That's definitely a cropland concern. And there's also sheet and rill erosion. So sheet and rill erosion, you can see in the image. I'm going to try and turn on my pointer here. You can see the image here as you look down the slope. There are some evidence of rills, and rills are areas of concentrated flow that have started to develop into a gully, but it's a very shallow gully, and it can be addressed with tillage. It can be, kind of, I don't want to say eliminated, but it can be mitigated and managed through tillage. Sheet erosion is when you're basically losing water, and you're having water move across the surface and losing soil with that water kind of in a sheet, thin sheets. It'll just kind of move right across the landscape, almost like a blanket, or if you see really heavy rain running down a window, it looks just like that, but it's moving across the landscape. Oftentimes we speak of sheet and rill erosion together because you can sometimes see them occurring at the same time on the landscape. And for some of our erosion estimation equations, such as Russell 2, they estimate sheet and rill erosion. So you'll often hear those two types of erosion discussed together. There's also ephemeral gully erosion. We discussed that a bit yesterday. That's different than classic gully erosion. They are generally wider than they are deep. You can till through them, although it's better to stabilize them with some sort, and we'll look at that in a minute, with some sort of grass. But they often erupt kind of unexpectedly, and often where there's land use change. So there are different types of erosion that we'll discuss as we look at and consider as we look at these different types of practices. There is a conservation catalog that's available that provides kind of a summary of all of the conservation practices, and this kind of works together with the Electronic Field Office Technical Guide, specifically Section 4, that's often offered through NRCS. So we'll just be looking at kind of a subset or some highlights from the catalog and from the Electronic Field Office Technical Guide. So best management practices, often known as BMPs, these are practices that can be used generally as a system to mitigate and reduce resource concerns on cropland. And I think it's important to remember we often talk about practices individually, but when they're installed or when they're included in decision making, typically or often they're a system of practices. So conservation crop rotation, this is a sequence of crops. They're basically grown in the same area on the same field over a period of time, and they cycle. There's a variety of reasons for implementing a conservation crop rotation, and we'll look at those. The duration can be anywhere from a very short rotation. Sometimes you'll see 2 years up to 6 or 7 years, which you may see those longer rotations, specifically on dairy farms, where there's a lot of forage that needs to be grown to support the feed needs and the feed inventory for those animals. But conservation crop rotations have the ability to address resource concerns associated with sheet and rill erosion that we looked at. They can definitely maintain soil health because they add and support organic matter content in the soil. It also affects how the water moves across the landscape. So you can often slow the runoff down. That helps with eliminating the loss of excess nutrients. It also allows the soil to retain more moisture. As I mentioned, oftentimes the longer rotations will have a forage, like a multi-year forage growth in them. So, for example, like 3 years of corn and 4 years of forage, and that's for domestic livestock, often dairy. The farmers need that forage as part of their feed inventory. You can also provide food and cover and habitat for wildlife, including pollinator forage, when you have this kind of conservation crop rotation. So there's a lot of different pieces that you can think about when you're talking about conservation crop rotation, but it does support soil health, organic matter, and it reduces that sheet and rill erosion concern. This is an example of what a conservation crop rotation may look like on the landscape. You can see the alternating crops up here. And then what would happen is this field, for example, will maybe rotated into a different crop. But there's a sequence that is moved through on a multi-year cycle. So the same field may go through, and we have an example up here of 1 year of corn grain, and 1 year of soybeans, and that cycle will just continue. If you have a longer rotation, you may have 1 year of corn silage, 1 year of small grains, and then maybe 1 or more years of alfalfa and hay for that forage part. And that same field will just cycle through that rotation. And the other fields that are adjacent will continue to cycle through the rotation. Most farmers do have some sort of crop rotation, but when you have a conservation crop rotation, it's a bit more intentional because you are trying to address those resource concerns while maintaining, if you're a dairy operation, enough forage to support those feed inventories. So contour farming is often seen in Pennsylvania. It's seen in sometimes on more steeply sloped areas. And what it basically does is it aligns any types of ridges or furrows or roughness that may be associated with tillage or planting or operation along the grade of the contour. This definitely reduces the velocity of surface runoff that's coming down the landscape. It allows those furrows and ridges to kind of slow that water down, to capture it, and allow that water to infiltrate. It definitely addresses the resource
Cliff.
concerns
Good, how are you
With
doing?
with sheet and rill erosion. This in turn reduces sediment transport, as well as nutrient transport to surface waters. This is an example of contour farming, and you can see that the way that the fields are laid out is similar to, kind of the contour or the topography. If you've ever seen a topographic map of the area or topographic map in general, if you have contour farming installed or that practice installed, you're going to see that the fields look very similar to that topographic map. And that is intentional to allow the water that's coming down the landscape to flow basically perpendicular to these fields and allow the roughness and the furrows to kind of slow down and capture that water. Strip cropping, which can be used cooperatively with contour farming, so you can have contour strip cropping in certain cases, is when you have a planned rotation where the crops include kind of an erosion resistant and erosion susceptible crops. And they're basically in a systematic arrangement on the field. So what you're doing is you're creating zones across the landscape where certain crops that need to be grown are more susceptible to erosion. And then as the water kind of moves through and the soil moves through those areas, they will then kind of be intercepted by a field, for example, or a crop that has more residue, and it'll slow that water down. It will allow it to infiltrate, and it will prevent accelerated erosion. So here again, we are addressing sheet and rill erosion, reducing excess nutrients into surface waters for water quality concerns, sediment transport, and this can really improve plant productivity as well as health. So you can see these kind of three practices, the conservation crop rotation, the contour farming, and the strip cropping, in a way all work together. You are addressing sheet and rill erosion and subsequently preventing sediment loss and nutrient loss. This is an example of what strip cropping might look like. In this case, it looks different than the contour farming because it doesn't kind of look like that topographic map, right? The fields are laid out more just as strips as opposed to along the contour, but you can combine them where you use the strip cropping on the contour as well. So this is an example where you have hay here, you have oats here, and you have corn here, where you have different crops, with hay being more erosion resistant and corn, depending on the amount of residue, being less erosion resistant, for the hay. The corn, depending on the residue, is generally more erosion susceptible. So you would combine those different types of crops across the landscape. Cover crops are becoming increasingly popular, used for a variety of reasons. And they're generally grasses, legumes, or forbs. And forbs are herbaceous flowering plants that are not grass. So clovers are a good example of a forb. And you just basically grow them, usually over the winter. You can reduce erosion. This way you keep the ground covered, right? There's not as much bare ground. This can definitely increase and address soil health concerns as it increases the amount of organic matter. You can break pest cycles as well as weed pressures. And this also helps to minimize soil compaction. Oftentimes, because there's more root activity throughout the year, the roots can grow down through the soil compaction. And that also helps with soil moisture use and also retaining or scavenging for nutrients. So cover crops are an important part of the crop rotation sequence and can definitely address some of the primary conservation concerns we have around sheet and rill erosion, but also compaction, which speaks to and improves soil health. So this is an example of some cover crops. Here, this is an example of a forb. This would be red clover with triticale as a cover crop. Over here on the upper right-hand side, we have oats combined with tillage radish. And if we go down here to the bottom left, this is an example of a tillage radish. And this type of cover crop is very useful if you do have compaction, especially surface compaction. It can help break that surface compaction up. It also creates, we talked a little bit about pore space and macro pore for allowing the water to drain through what was possibly a compacted soil. So has become an increasingly popular and important part of cover cropping. This is an example where there's cover cropping around shocks that have been harvested and managed by more conservative farmers. And you can see along here, they have taken the steps to put a cover crop in place to cover that bare ground. So residue and tillage management for no-till. So no-till is fairly widely used in certain areas of Pennsylvania. It really limits, the idea is it limits soil disturbance to manage the amount and the orientation and the distribution of the crop and plant residue on the soil surface year round, right? So you have minimal soil disturbance. There is still some soil disturbance, but it's minimal. And when that's combined with residue, you can reduce that sheet and rill erosion. We don't have as much wind erosion in this area of the country, but in the Midwest, they do definitely have more wind erosion and excessive sediment loss in surface waters. You can reduce particulate emissions with no tillage, because tillage can create emissions just by breaking up the organic matter in the soil. So by having less disturbance of the soil, there's fewer emissions. Definitely, you can maintain soil health and organic matter content, right? The less disturbance there is, the more organic content there's going to be in the soil. You'll have more available moisture in a no-till system, reduce energy use, and you can also here provide cover as well as food for wildlife. So there's many benefits to no-till when it comes to our resource concerns, from erosion to organic matter. So this is just some examples of the residue that's left by different no-till operations. This is soybeans being planted into kind of quite a bit here of corn fodder or corn residue. Over here we have soybeans being planted into small grain residue. And on the bottom left here is an example of a no-till operation where you can see that really the only disturbance in the field is where the plant, where the discs are making a cut, basically disturbing the soil here to plant. So you can see that it's not disturbance across the entire field, but only in specific locations to complete certain operations. So there is still some disturbance, but the disturbance is minimal and it's not across the entire field. It allows for better residue management as well as the minimal disturbance. So with reduced till, that's a little bit different than no-till. Here you're managing the amount, the orientation, and the distribution of the plant residue and the crops, and it is still year-round by limiting the soil disturbance activities for harvest as well as growth. Harvest as well as growth, where the soil is tilled prior to planting. So again, here we're looking at the conservation concerns or the resource concerns associated with sheet and rill erosion and loss of excessive sediment to the surface waters. We are again reducing particulate emissions because we have less disturbance of the soil, less degradation of the organic matter associated with the soil. Also, you're improving the soil health or maintaining a certain level of organic matter. So if we look here at reduced till, you can see in comparison to the plantings, there's less residue. There's still residue between the planting rows, but it's less than with the no-till because there is more disturbance with the reduced till. And this is an example of a reduced till operation. Again, more disturbance than the no-till, but it's still within specific locations of the field and not the entire field. So very similar concepts. It's just a different types of operation, different types of equipment, and you will see generally less residue with the reduced till. So nutrient management is an area that I'm sure many of you will be involved in within your careers. And here we're looking to manage the rate, the source, as well as the placement and timing of plant nutrients, kind of, the 4 R's, right rate, right placement of the different soil amendments, and looking to reduce the environmental impacts. So maintaining crop yields, maintaining an agronomically viable soil, but agronomically viable system while reducing the environmental impacts. So the standard for nutrient management with NRCS is the 590 standard. And the idea here, some of the concerns are plant health and productivity, achieving yield goal, achieving the management goals of the farmer, but at the same time, reducing the nutrients in the surface and groundwater. Emissions, here we're looking mostly at odors, as well as particulate matter, greenhouse gases, and ozone precursors. So some of it's related to tillage, some of it is related to the application of the soil amendment, or most frequently manure, but not always. There's also concerns about pathogens, potentially from manure, biosolids, and compost applications. So that's part of nutrient management. We are concerned about surface water, but also groundwater. How are the amendments that are being applied? They're using the methods available affecting the surface water, but also potentially the groundwater. And we do definitely want to go back to soil health by maintaining that soil organic matter. So nutrient management really encompasses a lot of different pieces when it comes to, recommending nutrient rates, and as well as nutrients and soil amendments. This is an example of, some of the testing that you do, understanding what the analysis is of, in this case, a fertilizer. What nutrients are you applying at what rate? Manure analysis is used when you're applying manure. Taking tissue tests of your plants can be important to understand what the nutrient status is. Soil sampling is a key part of nutrient management to understand the fertility level and the fertility status of your soil. And this is an example of manure being applied to a field, manure amendments, and how that rate and how that application method fits with the overall goals of nutrient management to address resource concerns. So filter strips are also address a resource concern, specifically, reducing suspended solids and associated contaminants that may be in runoff or excessive sediments from surface waters. And they're basically a strip or area of herbaceous vegetation that remove contaminants from overland flow. The strip is designed to slow down the surface water, reduce the velocity, allow that water to kind of move slowly across the filter strip. This allows solids and other nutrients to kind of filter out across the filter strip, which is why it's called a filter strip. So it's very effective in reducing that velocity and really reducing suspended solids. Oftentimes you'll see this also used with irrigation water in areas where irrigation is more common. This is just some visuals of what filter strips might look like. Here along the edge of a field, right? It's the runoff, the surface runoff or water could potentially move across this field. It's going to hit this filter strip. That velocity is going to slow down, and you're going to start seeing suspended sediments and associated nutrients kind of filter out or fall out as that water more slowly moves across that filter strip. So grass waterway, these are typically used. We talked a little bit about concentrated flow areas yesterday and earlier in the presentation about gully formation. Grass waterways can be used to prevent gully formation, maybe where you're starting to see a rill form that you're repeatedly having to address through tillage, or you're starting to see a concentrated flow area. Installation of a grass waterway can help prevent a gully from forming there. Basically, it is a shaped and graded channel. It's established with vegetation, specific types of vegetation that convey the surface water. The velocity is slowed down within a grass waterway to the level or the point where it is non-erosive. So it's going to be broad, and it's going to be shallow, and it's going to have a stable outlet. So this is a little bit different than a filter strip. You're looking to design it to achieve a specific velocity. So you're going to protect and improve water quality here, as well as prevent the gully formation. And these can also be used in combination with terraces and diversion and other water concentrations as outlets. So these are just some examples of installing a grass waterway, and also what the grass waterway may look like when it's finished after the geotextile has been laid down and this gully has been graded. So we have a gully in the upper left. We've graded that in the upper right. We've installed the geotextile to kind of support or stabilize the grass waterway. And then here in the bottom right, we have the grass waterway installed. This is another example of a rock-lined waterway. On the left here, sometimes rock-lined waterways need to be used if there's the expectation that there's going to be high velocity waters where the grass can't or vegetation can't be used to kind of slow that water down to a non-erosive velocity. Rock-lined waterways may be used in those cases. So a diversion is a channel that is constructed across the slope with the supporting ridge on the lower side. The idea or the point or the objective of a diversion is to break up concentrations of water across very long slopes. They can also be used where land use changes to kind of protect the land use below. So for example, if you have a farm field that is below an impervious surface, you may have a diversion there to capture some of that surface runoff that may be moving at a fairly high velocity from that farm field, which may be effective if you have ephemeral gullies that are emerging there. You can divert water away from specific areas such as farmsteads or agricultural waste systems. You can collect water, as I mentioned, and direct it for storage or for spreading. You can also use it to protect terrace systems, and we're going to look at them in a bit by diverting water away. So diversions are very effective in diverting water and controlling where it's moving, and it can also be used. Diversion can also be used to protect other types of practices such as terraces. So a terrace is a system. Generally, there's more than one terrace, earthen embankments, and it's a combination of a ridge and a channel, and it's constructed across the slope of the field, very similar to a diversion. But in this case, we have a combination of kind of these ridges and embankments, and they allow with a channel, and they allow the water that's coming across the terrace to be stopped, channelized, and then move across the field slope into some sort of retention area, such as a sediment basin. You can reduce and trap sediment, and you can also manage runoff. In the bottom left here, we have an example of a terrace. You can kind of see the ridge and the channel here, but in this case, they actually farmed through the terrace. Over here, you see a terrace system after there's been a fairly significant rainfall, and you can kind of see those channeled areas where they've captured or intercepted surface runoff and kind of moving that surface runoff to a storage area. So water and sediment control basins, these are earthen embankments, and it's a combination usually of ridge and channel constructed across the slope, but there's a minor drainage way. So they're really to reduce water flow and also gully erosion, again, kind of controlling and diverting away from those concentrated flow areas. They can definitely trap sediment, and they can reduce and manage runoff. Oftentimes you'll see diversions, terraces, and this type of sediment control basin or water basin used together as a system to both control where the runoff water is flowing and how that is subsequently stored. Again, we're looking at gully erosion, controlling surface runoff, as well as the nutrients associated with that. So this is just a few examples of a sediment control basin. Over here, you can see one, it's grassed, and this is an outlet, a pipe outlet for that particular basin. So that's the last practice that I wanted to cover with relationship to, those resource concerns around soil health, gully erosion, as well as sheet and rill erosion. If there's any questions at this point, I'd be more than happy to take them. I will be on the Teams meeting for the full morning. So if there's any questions that need to be addressed either in chat or, during a break, I can certainly do that. But thank you very much for the opportunity to join you this morning.
Thanks, Jen. That was wonderful. Sorry, I'm distracted. There's apparently somebody in here who's maybe not supposed to be in here. Not sure.
Is that right? So we're looking for our next presenter is Cameron Meyerly, and I was looking through the list. There's a couple people who don't have full names on here, and I'm wondering if Cameron's on or not. It doesn't look like it. So I'm still trying to chase Cameron down. He might be having trouble getting through on the link, so I'm going to reach out to him directly. The presenter right after Cameron is Justin Brackenrich. Justin, would you be willing to start your presentation now, or?
Yeah, I was going to use another half an hour to work on it, but if everybody's willing to take a half done, I'm just kidding. No, it should be fine.
All right, wonderful. Then we will skip forward on the agenda for the moment, and we'll jump to over livestock and right to pasture management with Justin Brackenrich, who is Penn State Extension educator on our agronomy team and real grazer kind of guy. So, Justin,
Okay,
you
Jen,
should be
you're going to
good.
have to help me.
Okay.
Teams is not my typical platform.
That's
So
all right. You're doing so far so good. It looks beautiful.
that's what we need.
Yep, you look great.
Okay. Do you want cameras on or not?
Nah, you're fine.
Okay. All right. Good morning, everyone. You have to bear with me as I collect my thoughts. I was expecting to have another half an hour. Yeah, anyway, so let's get started. So pasture management basics. How do you take something that you've spent a long time spending your life with and submerging that or summarizing that down to basics in 30 minutes? We're going to go through a lot of these management strategies, right? There's grazing and there's grasslands and there's the things that make sense and don't make sense. But I want you to keep in mind that this is a very complicated topic, right? I want you to form your own opinions about what makes sense in grazing and grasslands. And I want you to do the reading when we're done here. I don't want you to take what I say to you and then you say, this is what I need to do with my career. This is what I think everyone should do, right? There are people, fascinating people doing lots of literature and lots of research on grazing and grazing practices. And the really interesting part about this is it's not a one size fits all, right? The topography of the land doesn't always lend itself well to strips or rotation or this very rigid type system. And not everyone's climate is the same. And so I think that's what makes this such a wonderful process and why people can really get into grazing is because it can be so different and give you such a challenge. I would have liked to have been after Cameron, but our first thing is I'm not a vet, right? So when we talk about grazing and animals, it's kind of hard to do this without talking about animal health concerns. But at Penn State, we always throw this kind of disclaimer in there that if I talk about animal health, it's animal health in a form of education. Please don't take any of this as to be medical advice. If you see anything with someone's animals, if you're on a farm, what you're giving them is advice or what you're giving them is knowledge, right? If they have issues with their animals because of grazing, consult with a veterinarian. We are not that. What I want to run through is just a little bit of general on what is pasture, what is management of pasture and grasslands. I think it's important that we talk about, yes, this is management. No, this isn't management, but why? Why do we care about this stuff? So often we get these things of, we need to do this, we need to be better at it, but why? Why does this benefit us or our livestock or more so importantly, economics, right? If we're not paying our bills or we're not making money, we're not farming or we're not producing. And so I think that really becomes kind of the big thing here. So then we're going to kind of close off with some fertility and weed management because that's part of pastures, right? We have to make sure that they're viable, they're producing, and that we're not seeing decline with them in slow periods. So I looked it up. It's kind of a very textbook definition. The state of Pennsylvania defines grasslands, right, mostly as a treated feature, but it has to be treated. This is a treatment using animals to manage grasses, forbs, residues, and shrubs. And so we could look at something like CREP or an abandoned strip mine or something like that that may in fact be grasslands, but it's not this term that we're looking at as far as pasture or grassland because we're not treating it, right? It's existing. It does have a lot of ecological benefits. It does kind of do some of these boxes that we're going to look at, but we're not treating it to reduce some of these things. We're going to improve our soil nutrient and soil health because we've got this livestock and plant interaction. We can reduce erosion because we're going to have soils and grasses that are held. These roots are going to be holding things in place. We can reduce some runoff and erosion because of better permeability and better infiltration. And mind you, the important part of this is management, right? We want to keep all this in mind because I've seen a lot of very unmanaged grassland systems produce very similar amounts of erosion as what you can see on some no-till or moderately tilled cover cropped or row cropping systems, right? You get very steep, you have no grass. That can still lead to erosion. So we have to keep management in context. We want to prevent invasive species movement. That's where we kind of think more about this. What happens if it's in CRP or something like that, right? That management is done by the producer mechanically or chemically or something like that, where we're tending to think that management can be done a lot with our livestock and running that down through grazing or foot traffic. We're going to reduce our energy use. That's thinking output energy, things that we're bringing in like fertilizer, but we're going to be using sunlight to grow these and harvest them. We're not using tractors to do it. We're increasing our diversity. And then the last one, right? We're producing food to a very hungry world and a very big place that needs food every day more than the day before. And so that's kind of the bottom line to this, right? All of this kind of culminates in this thing that says we're producing food and we're staying in business. So now we're going to look at what are management systems. And these can be, we see this continuous graze that's got kind of brought up here. And I think that we can forget that continuous graze is still part of a grazing system, right? There are areas that we can say this is continuously grazed. They're thrown out in May and we come back in October and we see who's alive. That's not a management system, right? That is this continuous stocking. Where we can see this is continuous stocking kind of left in this pseudo rotational, if we will, that maybe we're in an upland pasture and economically, it doesn't make sense to try to get water to this place that we can divide it as well because it's 10 acres or something, right? We bring the cattle up there, we continuously stock them for a while, then we bring them back down. And that field itself isn't divided, but it's part of a larger type system. And so we're quick to say, well, if this is continuously stocking, we're not doing anything good and we're kind of affecting our system negatively. But that is still one of our management styles that we can do with grazing. We're going to talk about the negative implications that come with that, but it is something we need to consider. We also have this continuous stocking where we have a surplus, right? So if we've got 50 acres, we're going to take 10 of it, fence it off when we get in this summer slump in the very dry part of the year. We can turn them into that 10 acres. We can let them have that. That's kind of looking at somewhat of an option between rotational or strip or stockpiling. If we were to do a more advanced type of this and we start looking at ways that we stretch forages longer in the year, that's where that would start to come up. Rotational, right? This is kind of the gold standard. This is what everyone wants to look at. This is where everyone wants to aspire to be when they're really in these heavy grass systems. We're starting at point A. We're kind of moving through as many of these as we can. What we're looking for is a longer rest period, right? So this rotation could be 4, 6, 8 hours, right? There are people that are rotating 2, 3, 4 times a day. There are people that have their paddocks set up that they're rotating every 2 to 3 days, right? This is the system that your infrastructure allows. This is where the folks like you that are coming into conservation districts or NRCS has such a wonderful platform that you can work with producers to give them the opportunity to work with you and develop fencing, get the grazing plans, work with the watering. Usually the biggest negative to this is they don't have the infrastructure, right? They've got 1 or 2 hard troughs that they're trying to work off of. And we're going to talk about the negative side to that. But educating is my job, right? I can get out there and I can talk to them about it. But what I don't have is the ability to come out and help them design this to make it work or help them put this to a scale of their property. And that's where you guys have such an important role to play is getting people to this rotational stocking aspect. And then last is strip grazing. So strip grazing is very similar to rotational grazing, but in the sense that we're not kind of looking at these squared off paddocks. Let me see if I can find my... So we're not looking at it as much of this kind of circular and we make this very square, easy going rotational, but rather we're kind of stripping this across a field. We're going to the end and we're starting back. Where I see a lot of this gets used in strip grazing is kind of within a rotational system but we see strip grazing used on crop ground, whether it's corn stalks or someone using some summer annuals or something like that, right? We call this back fencing, meaning we let them graze this field, this little strip for a little bit, then we can move them up and back fence this. We move them to the next one and back fence. And when we're talking about a lot of our annual type systems, as we start over, we tend to not back fence, right? We can let them move through and then they can graze the whole way across. So strip grazing is kind of a modified system of this rotation. So when and where, right? How are we going to do this, right? This is going to reduce the selectivity of grazing. We'll really kind of focus on that a little bit when we get to the weed management. It's going to give us much better manure distribution. I wish Cameron had been here to talk about some of this, maybe, and maybe if he's listening now, but parasite reduction, especially with sheep, grazing, we're not grazing as low, we're not grazing as frequently. We can really start to control some of that by using these rotational grazing systems and these better managed. We can increase our stocking rates and our carrying capacity. We're going to look at that in a little more depth, and we can improve stand longevity. That to me goes back to the economics of this a lot. If you were doing this years ago, right in the late 80s, early 90s, there was this big phenomenon called steady orchard grass decline, right? And these farmers, they started experience orchard grass stands just falling off, and they used to be a 20-year stand, and now they're a 10-year at best. It could cost $500 an acre to seed these forages, right? They're a very long-term investment. And if you're not able to get 5, 7, 10 years out of something and kind of depreciate that at $50 a year, it really starts to be more difficult to justify these stands. And so that's kind of where I really like to see this. We're improving the longevity of that stand. We're allowing these desirable species to show and grow and exist compared to continuing to just have Kentucky bluegrass dominate these stands. So how do we get here, right? What's the why? How do we go out and we talk to a farmer and we say, yeah, we're gonna work on this rotational grazing. We're gonna work on some management stuff. These are the benefits. I can lay you out this laundry list of things, but what's gonna happen? How do we get there? We want to maintain an optimal sward height. That's a really big part of this. There's a lot of reasons. It's going to help our below ground that we're going to talk about. It's going to talk about our regrowth and how fast we can do that. There's some really great research that's been done on species even that says if you're at smooth brome, you need to be a little bit higher. If you're at orchard grass, you can go a little shorter. Typically, we're looking at this at some different areas, right? There's some practices that say we take half and leave half. There are some that continue to go to this 3.5 to 4.5 inches. I think that's working with your producer. That's working with the knowledge that you gather while you're doing this to find what fits, right? My goal is get them to not overgraze it. If you can get them to take one step to not continuously graze, not overgraze, you're not seeing bare soil, they're going to do a little bit better. And then the next step is going to come from them. They're going to say, okay, hey, I saw a great improvement of that. What can we do from here? We're going to limit our nutrient management additions. If we have to apply fertilizers, we will. A lot of times folks will kind of get caught up in this grazing thing and they'll say, I haven't bought fertilizers in years. What's happening though is we're feeding hay or we're feeding mineral or we're feeding grain. Essentially, in rough numbers, 80% of what that cow or that sheep or something that livestock is eating is returned back to that field. And so if we're feeding a ton of hay out there, we're essentially returning 40-ish pounds of nitrogen and 10 to 12 pounds of phosphorus and 40-ish pounds of potassium per ton of hay that we're feeding. And so if we're getting that out there on that pasture field during the winter or during dry periods during the summer, that kind of becomes our fertilizer program, right? So that is kind of what we're looking at here. And I'm giving you this because you'll hear farmers say that I haven't bought fertilizer in years. Don't get caught up in that. Don't go out and tell all your other producers you need to do it like them because they're not buying fertilizer. Understand that their fertilizer is their hay. It is their nutrient that they're buying, whether that be mineral or other stuff. And consider with rotational, we're also getting better distribution of that manure and that urine. So we talked a little bit about how this affects, right? So if we've got this short grazing period, we're turning these in, let's call this 2 days. We've got a pretty tall sward height, let's call it 12 inches. We're going to go in there and graze a fairly short period, and that's going to give us a long recovery time. we tend to mirror above ground what we have below ground. As we get into more of these longer grazes, right? If this one was 1 to 2 days, if this one's 5 to 6 days, and that 12 inches goes down to 1.5 inches, now we start to see these roots, right? Because we're not able to get enough carbohydrates. We're not able to get that solar panel activity working up on top. The other issue we start to see is mostly what we're farming are cool season grasses. As this soil surface starts to heat up, we start to see tillers die on the edges. We start to see root sloughing off. That material starts to go away. And so the more of this we can keep up here collecting sunlight, the less we see it actually infiltrating the soil and heating up our soil temperatures. As we move on even further to continuous, right? This is just where they're selectively grazing everything they like. We see a very low amount of root. And that can even manifest to a point where if it's very muddy or if we're in a wet area, they can actually go to forage on that. You can see them pull that up by the root because there's just not enough there to hold it in place when they're trying to feed. And so this kind of where some of that take half, leave half comes in. We're going to look at this as what happens if we do take half and leave half versus going from taking to that very typical kind of height. So this work was done in Kentucky by Dr. Ray Smith, and this looks at some orchard grass that they cut at 3.5 inches in height versus 1 inch in height, and they let it rest for 5 days. A lot of times farmers and producers want to cut or they want to graze very low because they think I'm not getting more out of this, right? I'm wasting all of this material down here on this crown unless I'm cutting or mowing very low or grazing very low. With something like this, it's very powerful to show them that in the same 5-day period, what we essentially got out of this 1.5 inch was the regrowth that we took this to at 3.5, right? And so if we had another one of this height, we have a lot better canopy closure. We're going to be reducing some weed issues that could possibly come in there. We're going to be increasing the flexibility we have with grazing, and we're going to be able to get in there much quicker. So back to some of these strategies for grazing. It can be pretty simple, right? This can be as easy as having this perimeter fence, right? Let's call this one field. We've got a watering trough. The key to this is to split this pasture. If we've got 10 acres, we can split it in 2. Maybe that allows us to get 5 days of rest on this side, 5 days on this side, right? That's where some of these grazing spreadsheets and Excel sheets and stuff start to come in. We divide it right up the middle to our watering trough. Now, if we divide that again, right now we're looking at 4 different paddocks, and maybe this one's getting 2 days and 2 days and 2 days or 3 days. And we start to spread this out and we get this nice rotation, but we're still using this watering trough. And so that infrastructure exists. We're able to get that down. We're able to rest longer, graze them shorter. And if we back up, I don't know how far it is. This is what we're looking for, right? Shorter grazing period and longer recovery time is going to allow us to have better solar receptors up top, better root response. What I will caution you about, and you'll see this and as you start working with some of your programs and some of your engineering, this creates pinch points, right? There are always going to be mud on a farm. I don't know if I've ever been on one, and I've been on some very, very nice farms, that you're not going to see some type of mud. But the more of these type situations we create around water or around gates, the more of this we're going to see, right? This one was in winter, so I'm kind of making this look worse than what it is. But we can look at ways that you can engineer some of this with some filter fabric and some rock. But we need to address this, right? If we are going to do something like this around a watering trough, or we're going to be moving them in a gate, or we're going to set up this alley that we can funnel them down, there should be some consideration to, we know that there's going to be damage done here. We know that we need to reseed this, or we're going to have to fix this problem, because it can not only be this kind of growing issue, right? We start to see this soils get mixed into this homogeneous type mixture, and it becomes subsoils to the top and topsoils to the bottom, and it can be hard to grow. But it can also be an animal health concern. And so we don't want to let that stuff manifest. The other strategy we can talk about quickly is target grazing, right? We've got these areas where the livestock are really going to want to congregate around water or around trees, right? But if we have something like a feed bunk, we can move that to kind of get this deposition of manure and urine to different areas. what tends to happen is they eat out here in the field. This is where most of the nutrients are going to be because this is where the feed is, right? This is where our hay or our forage is that they're grazing. And then they're going to want to lay under the tree or loaf around the water. But by moving this feed bunk, we can kind of encourage deposition in a little bit different areas and have better nutrient management and a little less difficult time soil testing. The last thing I'll mention about this is a lot of farmers, once they do good grazing systems or poor grazing systems, they want to drag or they want to harrow or they want to do something. Big discussion could be about using of wormers and insecticides and things. And if you've got good dung beetle populations and nice earthworm activities, this is not necessary, right? If we've got a good grassland type system, it's not necessary. If we get a better rotational system, it's even less necessary because we're going to see this deposition. Typically where this distribution of manure is important is where we're looking somewhere after winter feeding. If it's somewhere that we've had them out all winter, they've kind of got this kind of mucked up area around a barn lot or around these gates, or you do have really bad areas, that's where we can kind of consider some of this to get that manure out. But really, at the end of the day, what happens is you kind of peel that manure up and it really doesn't travel much further than where it is. So the answer to that is still going to be target grazing or a better rotational system to get that distribution. Okay, so now I want to do a little bit of data, right? We have to have something to take this to a producer. We've said, yeah, these farmers get beat up pretty often about, you know, what I could do to improve your system is make you better at rotational grazing, right? I go out there and I talk to them and I say, well, what if we split this field? So we need to give them the why, right? Why or how or what does this matter to me? So this was done with ARS a few years ago. We talked about orchard grass, right? This take half, leave half. We got 12 inches. We're going to take it down to 6. We've got our standard residue height of 3 inches. And then we kind of simulated a overgraze type system. What they did was they went back every time they got to 12 inches. And this is kind of how it went. Over the course of the year, 44 days if they went to 1.5 inches. The grazing events, if we went to 6, it took 24. If we went to 3, it took 32. The important part that I kind of want to land here is we did get quite a bit of forage, right? We got 5,000 pounds of forage to the acre when we were overgrazing. We got more of it, though, when we were going to this 3 inches, and we got 5,400 when we stayed at this. We were getting 6 grazing events compared to the 4, and we had a much quicker return time because this was the amount we wanted to find. If we take these numbers, these actual yields, these pounds, right? These were the numbers that we generated of graze, and we throw some economics to them. I'm not sure when this study was done, December of 2010, so it's got some age on it. But the value of this, right, the economics, that's what we need to be. I think most of our producers are less interested in the economics than they should be, but this system is what was making them the money, right? This is where they were finding the most value. If we look at this in terms of hay, they were producing $325 per acre. They were producing $1,520 of milk per acre, right? That's the important part that we need to be figuring out how we get them concerned about is this is a dollar value. There are also people, so I'm in Western Pennsylvania, Southwest Pennsylvania. There are some people in some areas of Pennsylvania that their big concern is how early can I get them out? This also looked at how early the next season we were going to reach 12 inches, right? So if we grazed only to 6 inches and took them out, we had a much earlier regrowth, right? We were in early April, and I'm not quite sure where this study was, but that really helped with regrowth. The problem I have in Western Pennsylvania and over here is we're very wet in April. And so we don't want to encourage our producers to be putting things out in April anyway. But you could see a very significant difference between this overgraze and the time that you could actually get those livestock out on pasture. And that's something that can be very significant. I'm going to skip through some of these so that I can get back caught up on time. The last thing I will point out here about some of these benefits, right, is it's a fairly common practice, right? If we're talking about hay or silage or anything, the older the forage is we start to move from early vegetative into full bloom. The older this forage gets, the more of this fiber and lignin and dry matter we see, and the less protein and total digestible nutrients, and the quality really starts to go down. And so that's the trade-off, right? We get into these continuous grazing systems, and we're going to talk about undergrazed as well. We still see continuous systems that are undergrazed, where I see cows grazing or trying to graze this very tall, rank, stemmy grass. And it's mostly fiber, it's mostly lignin. We're not seeing very much at all of this leafy green grass material. When we're in this nice rotational system, we don't have to do as much clipping. We're not having to monitor because we're rotating through, and we're typically targeting somewhere between this boot. Boot is right when around that seed head is kind of emerging. We would call that emergence. But boot is somewhere between there and heading. And that's what we're looking for, right? That's that best ability for palatability, nutrients, protein, and that perfect spot that we want for those animals. So fertility. I think I've heard this I was watching some clips of the last one that the boot camp put together, and I think it's a very true point that I've said before, is that pastures or whatever wasn't growing a crop, right? So pastures tend to be some of the worst grounds on the property. They might be close to streams, they might be close to swales. Years ago, when we started looking at our farms and saying, what am I going to do with this? Someone at the farm decided, I'm going to grow corn, I'm going to grow hay, I'm going to do this. But we also had these very integrated farms, right? We had farms that were livestock and they were also crops. We've kind of lost that model now. There are some others still like that, but a lot of them are either crops or a lot of them or livestock. But everything that wasn't suited for growing a crop was then pasture, right? It was everything that was left over. And so it was treated some kind of poorly. We left the grass out there. We put the animals on it. We didn't usually fertilize it. But because of that proximity to water, it's really important to test for our soils because of other issues, right? If we start putting a lot of manure back on those, if we've got cropping ground, we tend to put manure there because we can control some of the weeds or some of the issues better. But we have to be careful about some of these environmental hazards related to water. If it's very steep and we see erosion control problems, if we start to load with phosphorus or nitrogen or something along those lines, right? It can also be very expensive, right? That manure may not need to go there. Those nutrients need to go somewhere else, but we can also underapply. Years and years of not applying nutrients to these things start to see them underperform. We start to see things like ironweed and sedge grasses and broom sedge and stuff like that. The Canada thistle really start to move in. And those are kind of indicators that we're not keeping up with our agronomic practice. We're not keeping up with our fertility. This study, they looked at about nutrient deposition and how we can get so spatial with what we've got, right? So up around the trees, they had lots of manure piles, right? Some of them were 50 to 60 piles per 500 square feet. And so what happens is we start to create these sinks. All the feed is eating out of here, left down here at watering troughs, left up here at trees. And so soil testing and fertility can be very difficult because if we continue to apply at a very standardized rate, if we're putting 50 pounds of phosphorus everywhere, this area could be very loaded with phosphorus, and there could be a stream right here where this area is very phosphorus void. And so that's where good soil sampling practices are very important, right? We have to sample the top of the aspect or the side of the hill, but we also don't want to put, if we see these really nutrient-rich areas, we don't want to put that into the sample with everything else because that starts to skew our data, right? If we know around this fence line that they're hanging out or these trees or these watering troughs, it's important that we keep that aside, right? We can sample that completely separate, and we can say maybe there's something we need to do here to start mining some of those nutrients out compared to some of our others. I'm going to finish up here on a little bit of weed management. I see I'm kind of closing in on time. What we run into with weed management, right, with pastures is we start to see this phenomenon of selective grazing, right? You look at this rotational, it looks very uniformly done here. This was left 14 days. This was kind of actively grazing. We see it's very uniform here. You can see things like the milkweed starting to show back up. You can see some Canada thistle. You can see tufts of stuff or some tabletop areas. What this means is we see this kind of a halo effect, right? If you've got this thistle right down in here And we say if we have a pound of thistle, we're also losing a pound of desirable grasses around it because they don't want to put their snoots down in there and kind of get their noses pricked and stuff like that, right? And they're starting to say this number may actually be more like 2. And so for every pound of weeds, we have 1 pound of undesirable, 2 pounds of other stuff. We're starting to reduce some of our useful and some of our grazing area by 3 pounds, right? And so that really can add up. And I know there are lots of discussions I have with producers, and they say, well, my livestock will eat multiflora rose, or my livestock will eat milkweed and Canada thistle. And I think that those systems exist, and I think that that's one of the things of a rotational grazing system is we do suppress a lot of that selective grazing. But I think we need to be in tune with what things are on our noxious and invasive species list, right? So if multiflora rose is there, we need to remind them like, yeah, sure, maybe they do, but we should not be allowing these things to just kind of go unchecked, right? If they're grazing it, that's great. But in the areas that you're not actively grazing, we should still be controlling things like Canada thistle and Japanese barberry and all of these other things that may end up being a problem, and not encouraging our producers to be out there just trying to have bad weeds so their animals will find out if they eat them or not. When we have these overgrazed areas, we start to see a lot of grass. Competition starts to phase out, right? We see a lot of annuals here. We see these plantains. We see some crabgrasses. We can go in here, and if we started to apply fertility practices to this, or we started to rotate our livestock, right? If we started to put a bale of hay right on this, or we put our feeding area adjacent to this, the fertility is really going to be helpful to these kind of things, right? We can build some organic matter. We can get some of those seeds of the grasses dispersed in there, but it does still become weed control, right? These weeds are here. What we're looking to do are fill these areas in so that there's not that seed to soil contact and allow them to kind of show up. This was this discussion earlier about overgrazed versus undergrazed, right? This is just as bad as what this is, and in its own right, probably even worse, right? There may be some more animal health implications to undergrazed pastures and them waiting around and all of this. If we think about ticks and vector-borne type diseases and some of the other issues that would come along with that, compared to this, where it's maybe more of a hunger thing, but we can supplement to that. As we overgraze, we start to release some of these understory things like horse nettle and amaranth and thistles. When we're in this, we start to release more of our woody herbaceous stuff, right? Our multiflora rose, our barberry, our autumn olives. That's what starts to kind of express there. This study was done looking at continuous versus rotational grazing on a percentage basis, right? As we rotationally grazed, weeds went down, right? They were almost 10% in the beginning. By the end, they were somewhere around 7. When we continuously grazed, weeds kind of bounced around somewhere between 7 to 8, almost 9% of that competition. What we do also notice is we continuously graze Kentucky bluegrass, right? That very fine sod forming grass starts to really push towards domination of these stands. It's great for holding sod, but it's not wonderful for feeding animals. Orchard grass goes down. We continuously graze. We start to take away some of the desirables we want. As we start to do better with rotation, those numbers actually go up. We start to encourage that. If you do see trees, right? So that's a discussion you'll see with your producers in pasture and grassland. It's hard to mow trees, right? So if we're going to mow them, we need to mow them early. If they get much bigger than this, then it becomes a much harder thing. And if we're going to do that, we need to target these annual species with mechanicals, right? We're mowing at seed head. I would encourage you, if you're looking at chemical options, most of you, if you were at the equipment demo, you got an agronomy guide. Look at that, use that as a resource, talk to someone within Extension, talk to someone that maybe is a mentor for you within NRCS or a conservation district. But these herbicides can be very specific to what they're doing. So be careful before you just start recommending herbicides on pastures, because there are not only the implications of the livestock that are there, but also residual effects and grasses and legumes that can be associated with that. So lastly, just a couple things, right? We need to leave enough residue so that the plant can grow back. We don't want to go through them too quickly, but we don't want to go through them too slow, right? If we overgraze, then we start to see that root slough. If we just blow through them too quick, we can't get all that information. The weeds and the grass is trampled down, right? Paddock sizing is very important for the number of animals we have. Returning animals to the pasture before adequate growth is going to be a problem, right? We don't want any less than 6 to 8 inches of canopy height because we don't want to graze it any lower than that 3 to 8 inches. And we want to start with a hard exterior, and typically we're going to use more of a removable interior. And in the fall, we can pull those up and let them clean up anything that's in the middle, just kind of push them through there, or we can mow that down. So I will stop and see if you have any questions, but I don't know how to, let's see. Okay. Oh, I stopped sharing my screen now.
There should be a little X in a box somewhere that if you hover over it says stop sharing.
Can't you just take it from me?
Well, that's a likely thing that we can do too. Jared's going to be going next. So Jared, if you want to just steal the
There you
screen
go.
share,
That should have worked.
you got it. And Justin, if you can stick around for a minute or two, folks can perhaps throw questions in the chat.
Sure.
As Jared gets queued up here.
Yeah, good morning. How's everybody doing?
Good. Thanks, Jared.
Sure.
And thank you,
Mm.
Justin, very much.
Give me 1 second here.
Sure. Paul, I'll let you introduce Jared.
Sorry. Welcome, Jared Boger. He's I'm not sure. Jared, what is your title? I apologize.
That's all right. I'm the civil engineering technician out of Harrisburg. I do a lot of CAD work. Give me 1 second here. I'm trying to do 2 things at one time here. I'm the CAD coordinator, the surveying, I guess, a quote unquote guru. I'm covering for some work in Lancaster right now. Yeah. and I'm doing this today too. So can everybody see that right now?
Yes,
Okay.
at least I can see it.
How
Looks
about that?
good.
Looks good? Okay. All right. So survey basics. This is kind of near and dear to my heart. It's something that we do every day. It comes with experience, and you could sit here and you could listen to me and talk about survey basics all day. But in the all grand scheme of things, to learn engineering surveying, you have to do it in the field. And this is going to be a quick rundown on some of the descriptions. But when we meet up in Union County in a couple weeks, we're going to go ahead and do all this stuff, and hopefully at that point it's going to make a little more sense. Okay. So here's a couple. I'm not going to just read these to you. I'm assuming you have these, but here's some references on actual survey basics itself. Some of it's in the engineering handbooks. There's a technical release, and then also the National has an engineering manual for the equipment that we use. So definition. Surveying is a science of art in which lines, distance, and angles and elevations are established. Here's a few different types of surveys. Plane surveying. This is assuming that the Earth is flat, and typically what we'll use is a laser level and a B2A. These two types of equipment you will be seeing here in a couple weeks, and the stations that we'll be using are these two. The stations that you'll be in will be using these two types of equipment. Geodetic surveys. Not sure if anybody has any experience in GPS, global positioning systems. It works through the satellites, and it's I won't say quote unquote easier, but it's beneficial and handy, especially when you're doing a fairly large survey. topographic. This is essentially, we can achieve this by any type of survey. We're just taking relative elevations, depths, and establishing some contour lines to do a engineering drawing. Engineering typically used during construction checks. I'm not sure the experience that anybody has on doing construction checks, but typically what I'll use is and you'll see one here, a hand level or a laser, like I said before. And then we have the aerial, the use of aircraft equipment too. So we survey in the field to determine locations, directions, areas, slope, rise or run, and volumes. Volumes determining cut and fills. Locations, we use locations to establish a suitable site for any kind of practices that we do, such as waterways or manure storages or roofed heavy use areas, or even some pasture. The last presentation you were listening to, we can use that too. So then we have areas, parcels, fencing, and then you have slope, rise or run with the contours, terraces, diversions, and waterways, like I stated just before here. We can represent these graphically with diagrams, maps, profiles, and then cross sections, and then with the designs also. Use of engineering surveys to collect data, design and lay out best management practices. And like I said before in the beginning, your survey skills are obtained only through practice. So like I said, we can run through all this and look at all these descriptions but really where you actually learn how to survey is out in the field and through practice. Here's a couple different types of survey equipment. The hand level and the laser level, and then also this is the B2A, and these are the more sophisticated type of equipment. And there's the GPS that I was talking about. The laser level and the self-leveling level are which would be the B2A. Those are the two that you're going to be having the stations here in a couple weeks. That's what we'll be using. Oh, and then you have a climbunner. Just a couple different things here. You have your tripods, you have your survey rods, you have your prisms if you're going to be working with a total station, and then you have also your data collectors. Measuring horizontal distances. You can use pacing. I'm not sure if you guys did pacing yet. I know that in boot camp they do your pacing, but you can measure horizontal distance by pacing. You can measure it by taping, wheel, and then also the stadia. You can even use it with a truck or ATV. And then you can, with the handheld GPS ArcMap measuring tool. I know I have a couple pieces of equipment that I use for certifying practices. It's a Trimble unit and then also a Geode. It's a piece of equipment that gets hooked up to my iPhone, and then that gets actually directly put into Conservation Desktop as a certified practice. And then also aerial photography. A few things here. Surveying, we got to take care of our equipment, right? We need to make sure that we need to keep all material or all survey equipment, including the instruments, secure when we're transporting. Adjustments and calibrations must be done at a regular basis. Maintenance, clean your equipment and make sure you keep extra batteries. And like I said, mistakes happen, right? It always does. I've broken equipment before. I'm not perfect, but just let somebody know that it has happened. And then storage, we want to make sure it's at a dry location, it's locked. there is 2 references that discuss some of these aspects here. Okay, so a lot, like I said, a lot of this we're going to see when we do our field stations, but it's nice now that we can take a look at, you have something to at least reference. Reading a survey rod. Let's see here. I'm going to go to the next slide. I like the next one slide better. So when we're reading a rod, this is, let me think here for a second. So here's 7, right? And so the height of it is 7, and then here's your 6. Let's see, here we go. 1, 2, 3, 4, 5, 6, 7. So that line right there is 7.67. So if you're reading through your Stadia or your laser level and it's in between this, we always want to make sure it's a lower. We want to make sure it's a lower line there. These are in tenths and then also hundredths. For what we're probably going to be doing, we would want to stay in the tenths, specifically if we're going to be doing any foreshots. But for a back sight, we want to make sure that we're going to be using the hundredths. And we'll be doing this in our field exercises too. Differential leveling, determining elevations between 2 points. A key terminology, you have your benchmark. Benchmark is it's what you start from. It's the beginning. It's a known point and it's an assumed permanent elevation. Backsite is a rod reading taken on a point of known elevation. It is the first shot after setting up an instrument level and then also establishing your benchmark. The height of instrument line of sight elevation is determined by adding the backsite to the known elevation point. So it's going to be the benchmark plus your backsite is essentially your height of an instrument. Okay. And then your foresight is any rod reading taken at any point at which an elevation is determined. So essentially that's going to be your side shots. That's when you're going to be taking the crucial survey points when developing or planning for a design. And then a turning point. This is an elevation that is determined by process of leveling, but is no longer needed when necessary. Readings have been taken. So, for example, if we need to survey behind a building and for line of sight, we can't get we can't see, we actually have to do a turning point to get elevations on that side, on the other side. That means when we turn, we got to make sure that we hit where we started so that we can make sure that we can hit behind where we're going. Okay. I know that's hard. It's kind of hard to explain. It will make a lot more sense once we're doing some of the field exercises. Let's see here. Give me a second. So like I said, for an example, we have a benchmark of 100. Our backsite is 5.26. To get our height of instrument, you have your benchmark, which would be assumed elevation of 100, plus your backsite is your HI, which is 105. This is just an example, 105.26. Okay, and then your foresights are essentially your side shots when you're going to be doing your topographic survey. Okay, and we would want to subtract your HI from all other to establish your foresights, you subtract your HI minus your 1.74, and that's your elevation of where you're surveyed. Field notes. We want to make sure that when we're recording these survey data, okay, we're accurate. We have some kind of integrity. The legibility, we want to make sure that if somebody goes down the road and sees these survey notes, we want to make sure that they can read it and they can understand it. Arrangement, and then also make it nice and have us and have clarity. Survey note keeping. This is probably one of the most important things when it comes to integrity and legibility. This is where we all start. This is where we start. We're trying to make a picture for something. Okay. It's important to fill out these titles. Okay. And then also do a diagram of where you're at. So this would be your field office. Your name would be your farmer. It's an individual, and then also a job, which is whatever for this instance, it's going to be a livestock pipeline. It could be a manure storage, could be grass waterway. Identification number, you can put, if it would be an EQIP project, you could put the contract number. And then also over here, you want to put your field numbers. It could be your track number. Up here, obviously, you want to put the date and then what type of equipment was used, but then include who's ever part of the survey equipment. You want to include their initials then too. You'll see these. I'll have some of these for our field exercises. Same thing as before. When we set these up, we want to make sure that we have a reference to the job, what practices we're doing, who's part of the survey there, and then also the date. Okay. So like I said before, this is hard to explain, but we'll understand a little better once we get out there and do it. Your first station is always your benchmark, right? So we're going to assume a planned elevation of 100. Okay. Our back site is our first initial point to establish our HI. And then HI is your height of instrument. And then obviously your survey reference is your benchmark there. And that's your benchmark elevation assumed of 100. So, excuse me, sorry. So like I was saying, to establish your HI of your equipment, you take 100 plus your back site. It's going to give you your HI. Okay. And then we want to round. So we have with the HI setup, we want it to the 100th, but from every when we start doing side shots or FS foresights, we want to make sure that they're at the 10th. Here's a diagram of trying to explain HI and backsite. So we have our elevation at 100. Right, our instrument height is elevated on this would be the tripod, and this would be your B2A or your laser. You take this is 100. You take your height of instrument, which was I think 5.21. Okay, so 100 plus your 5.21. That's your HI. Okay, just like that. Give me 1 second. So then these blue dots are representing your survey shots or your 4 shots. So these 4 shots is going to be your HI minus each one of these survey shots, and I'll show you here in a second what that is. There you go. So to get this, you subtract your HI minus your foresight, 6.3, and that will give you your 98.9. Excuse me. And then it continues all the way down through. Let's see if I can't show that. There you go. So HI minus minus your foresight gives you these elevations. Also, I didn't talk about this, but I should have. On the right side, and what you'll see in your survey notes, there's a place to do cross sections, but then there's also it's a good place to give a description of what you're shooting, right? So with your benchmark here at 100, we established that a piece of rebar, 5/8" diameter rebar, was staked in, and that's where our survey started. Okay, and it's good to point that out and put that in your survey notes. Excuse me, hold on. Man. And then also including doing your station or other, if it's important, such as, well, we're going to take a shot on a curb. You want to make sure that that's, for example, northeast corner of that curb, for example, and you want to make sure that you document that. Like we said before, a turning point, okay, is a point. It's a temporary point. It's a point that establishes a temporary point, but also to get around. If we can't see, if we need to take a shot behind a building, for example, and we can't see it from our initial setup, we need to do a turning point so that we can establish or get some more elevations behind that building. So let me see here. How do I explain this? So you take from at your station 2 plus 100. Give me 1 second here. Here, this would be, if you go to your turning point, okay, and you have to shoot back to where your initial setup was, right? You take the difference from where initial setup to where you are, okay, and then you would subtract from where your last shot was, and then that would be your new HI. Okay, it's hard to explain. It's something that we can show you when we're breaking down our notes in the field exercises. Okay, almost done here, guys. Survey note keeping. You're developing notes that someone not involved in the survey can read and understand later on. Okay, I've ran into situations where I can't understand somebody else's work, but I need to reference that design to make sure it's getting built correctly, right? So, for example, if you're doing a rebuild terrace, and back in 1970, these terraces were built, and there were survey notes taken on them. Okay, it would be nice for me to reference that material, to get a better understanding of what was designed, and hopefully, if it was designed correctly, use those notes and rebuild that terrace. I have never had this happen. Making your notes may become a legal document. I've never had that happen to me. Not to say it won't, but also take pride in your work and do it correctly also. Here's a couple common errors. Reading the wrong crosshair, the rod not extended correctly, transposing numbers, rod not plumb, equipment not calibrated, and I've done it. I've read the wrong benchmark. Here's what we'll be doing up in Union County in a couple of weeks. We'll have 4 stations. One will be a diversion and swale. One will be a stream corridor. The one station is going to be staking out and turning points. And then also there will be another station there, will be a topo survey. And all this will be using the laser or also or a B2A. Yeah. And that's all I have.
All right. Thank you, Jared.
Sure. Any questions? Sorry. Any questions?
Jared, since we have a couple of minutes here before we're gonna go on break, we were starting to talk a little bit about packing lists and stuff that people are bringing along with them, and maybe now would be a good time to just chat a little bit about
Sure.
equipment that folks might be wanting to look for around their office that they're bringing with them, like hand levels and stuff that you're hoping they'll have available to practice using during your exercises.
Sure. I would recommend, I only have so many surveying notes. I would recommend talking to your technicians or your engineers about getting some survey notes, or like a survey book or some of those notes that I showed in the presentation. I will have all the equipment. So no need for that. You may need some boots. We are going to get into the stream. And then also probably a rain jacket. Yeah. And then obviously pencil, and if you want a calculator too. So.
Hey, Jared, looks like we have a question in the chat.
Oh.
Can you only use pacing for measurement on a surface that is not rough?
Can you only use pacing for measurement on a surface that is not rough?
I mean, I think what the asker in Anastasia, correct me if I'm wrong. You're asking, is pacing acceptable on like a smooth surface, like a heavy use area? Is that an acceptable method of measurement for survey?
I got you. So I usually use pacing for preliminary stuff. Now I will use pacing for establishing a waterway channel at stations, but for something as like a little more complicated, such as a roof or such as a heavy use area or manure storage, I would not use pacing. I would use either topographic surveying equipment or also a wheel or tape. I'm hoping that answered the question.
Any other questions?
You're welcome. I'll be on here for a little bit if anybody else has any questions.
Yeah, I think at this point, we've kind of changed again today. The schedule, we've shifted some things around again for due to unforeseen circumstances. So
That feels like a good life lesson for this career path, right?
flexibility.
Yeah,
shifting things around.
flexibility. You got it.
So I think what we're going to do is we'll knock off here for a little bit, for a slightly longer than 15-minute break, and reconvene at 10.
I'll put that 15-minute timer up so folks know to get themselves back and we're not running too far behind, and maybe we can just get ourselves back into it again for a couple minutes before the 10 o'clock presentation.
Okay.
Yeah.
Yeah, sounds good.
Thanks,
So-
Paul. Thanks, Jen. Thank you.
Thank you,
Yeah.
Jared, so much.
Yep.
Are we back? Jen?
We're back. Look at that. Yeah,
Yes.
sorry.
Excellent.
Although we still have a couple of minutes till our 10 o'clock speaker, so we can keep having that conversation about things to bring or concerns about finding the tools you might need to be successful at boot camp. But it's too soon to start looking forward to the weather. But Jared made a very good point about bringing a raincoat with you. We're not going to reschedule boot camp if it's raining. We got to kind of keep moving and
Nope.
grooving. So yeah.
When Jen and I went through boot camp, it was rainy, to say to just speak plainly. It was quite rainy.
Just for
So.
the surveying activities, and we did fine for the rest of the week. So
Yep.
something about surveying and rain. So Jenna, I don't think that the list of materials has been distributed yet. Tim, are you on? Do you know if Shannon has finalized that and is sending that out this week?
I will figure that out here during the next couple of presentations. I'll reach out to Shannon myself and try and let everybody know. Tim is not on. He is indisposed.
Gotcha. That's fine. Jared, when you were setting up the stream crossing activity, did you know how deep the stream was? I see a question there about getting in the water and how deep a pair of boots they might want.
I'd say bring snorkel
Bring a
gear.
snorkel gear.
No, I'm just kidding. No, I'm just kidding. It's only like 6 inches to a foot. You'll be fine. Just bring some muck boots.
Great. Thank you. Nice
Sure.
shallow stream then.
Yeah.
They could potentially be the same as your farm boots then also.
Yeah.
So
That would be fine. Yep.
great. That'll work really well. I'm watching for our next speaker to log in. I did tell him 10 o'clock, so he might just be jumping on at the last second. So, let's see what else. If you do have a hand level in your office, that's something that is typically on the packing list. You'll be learning how to use those as part of some of the basic survey skills activities at our first farm visit, in addition to potentially during the survey activity days. Am I missing anything else? Jared, can you think of other stuff?
I was just thinking here. I think you hit it all. I don't
Yeah.
know. We probably won't use the hand levels for the surveying basics. I know they will be using them. I just don't know
At the
when.
farm.
Yeah. And then they do their pacing, and I don't know where they do those either. So
That's usually at the same time as the hand level, that same rotation on the second day at the farm. So
I got you. Okay.
very good.
All right.
So yep.
Well,
If you don't already know your pace, you will know it by the time that second farm day. And I still use mine to this day. So it's actually really handy all around the house.
that's right. That's right. So I'll see everybody in a couple weeks then. All right.
All right. Great, Jared. Thank you so much.
Thank you.
Any other quick questions from anybody before we roll into the 10 o'clock presentation?
Jen's Rob mine, and I am on board here. I don't know if you saw me.
Hi, Rob. It's good to have you here. We have you on for our 10:30 talk. I've got Cameron Meyerly is going to be right before you. Jared took over for his slot before break, and Cameron's coming on to do intro to livestock before we do the biosecurity deep dive. But
Good deal. Okay.
we're excited to have you present all about biosecurity this
I heard
morning.
you say something about missing speaker, and I thought I'd better chime in.
It's not you.
Okay.
You're doing a great job.
I'll chime in a half hour. Thanks.
You got it. Thank you. Paul, feel free to riff for a couple seconds here while I work on this.
Right. Filling dead space is a specialty of mine. So in addition, are there any other questions from the attendees about anything? You can unmute yourselves and just ask. This is a free space. Want you all to feel safe here. If not, we could sit in awkward silence. If anybody knows, oh, what the heck was his name? Late night host.
David Letterman. I'm old. Who are we talking about?
Craig Ferguson. Craig Ferguson.
Oh, that guy.
He would end interviews with in a variety of ways. He always had some sort of silly way to end an interview. He's a funny guy. And one of them, he would let the guest choose. And one of the choices was awkward silence, where they would then sit and just stare at each other, looking around awkwardly. I always found it hugely amusing to see what various people would do for those awkward moments. But since none of us can see each other, it's just verbal.
Hey, look who's here. It's Cameron.
I can see sheep.
This must be a talk about livestock.
That couldn't be. All right. We'll let Cameron take it away.
Great. Cameron, you should be able to share your screen, and while you're working to bring that up, everybody, our speaker here at 10 o'clock is Cameron Meyerly from our Mercer County Penn State Extension Office and our livestock team, who will be giving you a quick introduction to livestock this morning.
Yeah, I'm going to try to share my screen here. Can you hear me all right?
Can hear you just fine, thank you.
Perfect. I don't use a lot of Teams, so it's mostly...
Yeah, we're Zoom people over in the Penn State world.
Yeah.
So.
Yeah. I don't know how much they pay for
that fancy Zoom contract.
Yeah.
That looks great. You have it going.
You can see it. Perfect. All right. So we're just going to do a brief livestock overview and capture just the basics. Very simple, very introductory, and wanted to leave plenty of time for questions at the end, so be thinking of those. And I know this is a virtual situation, but if we can be a little more involved, that would be ideal. So in terms of where you guys are starting at, or experience in agriculture, how many of you have some livestock experience or exposure to that? Okay, we've got some hands raising, so fair amount. Okay, good. So we'll go ahead and get started here again. For those that have some experience, just sit tight with us, and certainly if you're sitting on some more in-depth or higher level questions, feel free. But again, this is designed and pushed towards those that have very little experience. So when we're thinking about the importance of livestock in agriculture, we really have to look at where it fits in. And so at the end of the day, all of our livestock species, or what our goal for selection is for our livestock species to be efficient producers of protein. Aside from if you're a vegetarian, a large portion of the protein that we consume as humans in our diet, and we have for a number of years, comes from meat, comes from livestock, or I guess if we go a ways back, wild game. So those animals have value from a consumption standpoint, and that's really where agriculture and livestock, and tying those two together, we've really seen growth in civilization and where we're at today. It's not just in the form of that protein and that meat fiber, but via milk. And so we use those livestock species for milk, meat, and fiber. And we're going to talk about some of those examples here in a little bit. Really where it fits in, and if you want to correct, are these all Pennsylvania residents?
Yep, all PA.
Okay, perfect. So when we're thinking about Pennsylvania, and there's a lot of other states, that's why I asked, when we're thinking about a lot of other states, we have acres that we cannot get equipment into, or that are just not as conducive for livestock production or for agronomic production, so or row crop production, so beans, corn, wheat, whatever. Hay equipment, we might have difficulty getting into the field. The slope of that field may not be conducive to mechanically harvesting that product for consumption. And so animals, the nice thing is they are mechanical in a sort of way, but they can get to places that we can't with equipment. And so we can use those non-tillable acres to produce food on, acreage that maybe doesn't have a whole lot of production value or use to us outside of recreation, can now be a food producing source and site for us. And so that's where, especially in Pennsylvania, we have a lot of that acreage just sitting there that, currently we're not doing a great job of utilizing to its full potential. But that's really where livestock fits in. That being said, there's a lot of livestock that's on tillable acres, and we're maximizing production on those acres to feed that livestock and thus feed ourselves and our communities. The other advantage to livestock is it offers diversification to other ag entities. And I've heard the example, if we look at the farm 100 years ago, maybe even longer than that, our farms today are very different. And so we've lost quite a bit of our diversification. It used to be that, you had 3 sows and a couple of cows, and everybody milked a cow for what the products that they were producing for themselves and for their local community. And now we've kind of put ourselves into these silos of production. So if I'm a grain farmer, maybe I don't have livestock, or it's unlikely that I'll have livestock. And if I have livestock, maybe I'm not doing these other things. Certainly, they're not mutually exclusive. And when we're trying to talk about sustainability and relating it back to profitability, that diversification can be key to seeing additional revenue streams come in, and really maximizing production on the acres that we're responsible for. So the biggest question is, where do they fit? So we talked about using them on non-arable ground, non-tillable acres where we can't get equipment. And my response is just about anywhere. I'm sure there's some pretty severe climates and environments that maybe we don't want to have livestock in from an animal health or welfare standpoint. But just about anywhere you could think of, we can find a place. If we can get a fence around it, and there's some places in the U.S. especially that we don't have fence in those range settings. They're highly adaptable to a wide variety of production systems. So we're going to see environments that are more conducive for confinement operations. A lot of our dairies would be considered a confinement operation, or at least confinement for part of the year. As we move out to the Midwest, when we're thinking about sheep and small ruminant production, the majority of those animals are housed inside. And when we think about kind of efficiency of use, and we look at acres that could be used for pasture to graze those animals, the value of that grain or that product that's being produced on those acres is far more significant than what we can use or utilize in pasture. So in that setting, it makes sense to move the animals inside and mechanically harvest that feed for them and deliver it to them. Grass-based production, that's what the majority of what we're going to see in Pennsylvania is. And a lot of times these two things go together. So maybe I have my cows out on, if I'm a beef producer, I'm grazing for 8, 9, 10 months out of the year, maybe if we're doing a really good job. And then maybe I move them inside, or move them to a confined paddock area there in the wintertime, so I can feed a stored forage or a hay or a silage to them. And so most of our operations are going to see a combination of these two items in production, especially in Pennsylvania. And then certainly we have to consider our range type operations, and we're not going to see that in Pennsylvania, but it's important to note, just it goes back to the point that they go anywhere. We can fit them in and they're adaptable. Our Western range type operations, cattle, sheep, whatever, they're grazing similar to what natural populations would have grazed many years ago. So some questions on labor use and threats to those animals, but something to be aware of. So again, we touched on that point and what you're probably most likely going to see. And so I'd be remiss if we didn't talk about why, especially on the sheep and cattle side of things, why do we see this adaptability, and what's their value in efficiency on that land that we don't have a lot of use for in mechanical tillage or those mechanical harvesting situations. That goes back to a lot of our species being ruminant animals, and all that's to say is they have a giant fermentation vat inside of their abdominal cavity that allows for the breakdown and digestion of fibrous material. So unlike you and I, they're able to consume grass and forage alone and live off of it, not only maintain body weight, but also grow from that. And that's via a symbiotic relationship with microorganisms that are housed in the rumen. And so as we walk through just the flow of digestion, and don't get caught up in the arrows, but we have the esophagus, and what ties to the front of the esophagus is the mouth. That's where that food is coming in. We also have an arrow that's going back out. And so a large part of this digestive process is mastication or chewing of that fiber over and over again. We're increasing surface area, allowing for more efficient digestion of that microorganism inside the rumen. And so if we've ever heard of animals chewing their cud, well, if an animal's chewing their cud, we can pretty much bank on they're a rumen or a ruminant animal. And so forage food stuff is entering into that reticulum rumen area, regurgitated, reswallowed, and then it's just a giant mixing vat of microorganism digestion occurring. And then from there, we head from the rumen into the omasum, and then into the abomasum. In the abomasum, you'll see those red squiggly lines because this was pulled from a parasite slide or a parasite discussion, which is mostly what I present on. So in that abomasum, think of that as being what you and I have as a gastric center for digestion. A lot of our chemical digestion, this is the true stomach of the ruminant animal. And then from there, we head on down to the small intestine, large intestine, where we'll see absorption of protein, absorption of water, and so on and so forth. So again, this isn't a nutrition talk, but important to note that there's 4 compartments to that ruminant animal's stomach. And because of those 4 compartments, that animal is very efficient at converting fibrous material that you and I cannot consume, or our other monogastric or single compartment stomached animals are not as efficient at digesting those lower value type high fiber component feedstuffs. So as we get into some of our livestock species, and I know we're missing some, I tried to hit the big ones in here, and we're not going to talk about horses today, and certainly depending on what group of people you're dealing with or talking to, I'd argue that horses could probably be in here. If we're utilizing those animals on the farm as our workforce and labor force, management of those animals are just as important as those that we're consuming for subsistence. And so we're missing horses in here. We're going to miss goats in here. And that's okay. And when we're thinking about just likeness, especially on the goat example, to our sheep, or what we'd call small ruminants, very, very similar, and very similar issues, production methods, and use that you'll see in Pennsylvania. But when we think about cattle, cattle is a pretty broad group of livestock classification. And so I'm sure we're all familiar with kind of the two avenues of raising cattle, and that's dairy and beef. And certainly we can divide that out quite a bit further into maybe feedlot production, whether we're a stocker calf producer, a backgrounder, a lot of different avenues to classify that information in. But the two main ones, dairy and beef production, they've been divergently selected to perform and produce a specific product. So at the end of the day, where our selection lies for dairy cattle, there's a couple of things. One, which is pretty obvious, and that's milk production. And with that milk production comes a lot of input from a nutrition side of things, whether it's in a grazing dairy or a more confinement intensively managed fed dairy. And the other aspect I would throw in there, and really what the dairy industry is placing a lot of emphasis on, is longevity, whether that's through immunological fitness, hoof and leg structure. All of these things go to a more productive dairy cow. If we can keep her around longer and she can maintain production, we've proven year after year that we can feed them to produce. And so as long as they're around and we're not losing those animals sooner than what we need to due to whatever other management we have, that is more ideal for the dairy producer. On the beef side of things, we're selecting, again, for kind of two avenues that I would classify. Maternal traits. So if we're a cow-calf producer, our goal is to select cows that are raising calves. We don't have a significant death loss. They're easy calving cows, meaning they don't need a lot of labor or assistance from me as the producer. And I'd also throw that longevity in there. We need those cows to stick around in the herd for a number of years because it takes too long for us to get them to maturity in their production cycle for us to call them out of the herd, CULL, meaning remove them from the herd for problems that we're finding or issues that arise. And so the other aspect, we're talking about beef cattle, shocker, we're producing beef or our protein product out of that beef segment of the cattle industry. And certainly dairy cattle produce male offspring that end up in the food chain. And I don't necessarily like to call them a byproduct of the dairy industry because we've really figured out, and certainly we have beef specialists there in Penn State who's really focused on the feedlot aspects of raising those dairy bred beef animals and looking at some terminal sire options with that. But we're not going to get into that today. We've really honed in and figured out how to manage those dairy beef individuals intensively in an efficient manner that we produce a very high quality product that enters into our food chain. So they're managed very differently. Certainly, we're going to see some similarities in if we have a grass-fed type dairy in our cow-calf producer. The majority of our cow-calf producers are going to utilize that non-tillable acres or acreage in Pennsylvania that allows for them to run a substantial number of cows. When we're thinking about space requirements, 5 acres to 1 cow can be pretty safe when we're thinking this region. And again, they fit a variety of production systems. So if I want to go out in your time, you'll probably see all of these different entities within Pennsylvania. It's a diverse group of producers, and so you'll see a grass-fed or grass-based grazing dairy. You'll see a confinement type dairy. Same on the cattle side of things. When we're addressing those nutrient management concerns or manure concerns that I think you guys have either talked about or going to talk about, we all have to deal with it. And so regardless of environment, production system, those are the things that we're trying to address. So again, just some little tidbits of fact, so that when you're out working or in discussion, just some things that hopefully are in the back of your mind, and you can carry on that conversation long term, and at least know the basics to sound like you know what you're talking about. With cattle, our gestation period is 9 months. That similar to what humans are. When we're thinking about mature size, there's a wide range specific to breed and production class of animal. But when we're thinking about mature size, 900 pounds to 1,800 pounds. That 900 pounds might even be a little heavy for some of our dairy breeds. So our Jersey cattle, relatively small. They certainly have value in their own right. And then when we get into our beef cattle, we can really see a range of that 1,000 to 1,800 pounds within the beef industry in and of itself. And I guess the same in dairy as well. We have some Holsteins that are getting pretty large. And this is just a side note, but what we're doing is we're raising that mature cow size, and as we're doing that, we are producing more pounds of beef. But with the decline in cattle numbers, we've actually seen a maintenance or maintaining of that beef output in the U.S. So that's kind of a fun little fact. One thing to touch on: genetic improvement through quantitative genetic selection. So estimated progeny differences. If you've ever heard of EPDs, it's essentially selecting animals that have improved performance based on numbers that are on a piece of paper. And these are not arbitrary values. These are values that have been developed by mathematics to look at selection or look at performance of those animals, of those genetics, and then from that attribute that into that math equation to give us a predictor for how the offspring is going to perform. On the dairy side of things, we can use these numbers to improve milk production, to improve longevity or immunological fitness. Long term, that's where we're headed. And then certainly on the beef side of things, items like weaning weight, calving ease, birth weights, those items can be very useful to a producer. I don't have to go out and buy a bull and hope that his production is improved from what I had purchased 3 years ago. And the other nice thing with cattle, and as a sheep producer myself, one thing I'm jealous of is the opportunity for introduction or incorporation of reproductive technologies. It's relatively easy to artificially inseminate, or AI, a cow. It's relatively inexpensive to artificially inseminate or AI a cow. And likewise, ET, or embryo transfer. If I have a cow, this heifer here in the top right corner, that is superior for, we'll say, growth and mothering ability, and I wish I just had another 10, 20 of her. The only way that I can do that, and I hope that it works, is, but I guess the traditional way. If I still have her mother, I can breed her mother back to the same bull, and hopefully I get a female, because these are single bearing animals. And that's a long process. So I wait the 9 months to get a calf that hopefully is a heifer, and then I wait another 15 months until I can breed her and she's in production. If I could take her mother, or say the heifer in this picture exceeds production of what her dam or her mother was able to accomplish. I can invest dollars into inseminating, superovulating that female, inseminating that female with a bull that complements her EPD profile, and then I can flush, and it's essentially just that, flushing those fertilized eggs out of the reproductive tract, and then place those into cows within my herd that do not possess value. And so next year, say I have a decent flush and I get 10 or 12 embryos out of her, and we get 8 to stick. Of those 8, I've now taken about 10 years out of the equation for replicating this individual. So again, a side note, and probably a little off topic, but these are things that hopefully you hear about, and certainly in Pennsylvania we're utilizing. We're not utilizing to the level we need to, but it is out there, and the technology exists at a economical point of sale. So kind of in my wheelhouse here, we're going to talk about sheep. In the classic example, when we go back kind of into agricultural history and look at why sheep were so popular, and we really come back to size. They're easy to handle. They have that flocking mentality. And so milk, meat, and fiber, really, I guess you could call it a dual purpose. You know, we can find animals that do those maternal things well in terms of the milk, terminal things well in terms of the meat, and then that fiber, I guess, would just be a bonus. Unfortunately, I should note that right now our wool is worth very little, and certainly we can get into an argument with those that are maybe part of a spinning guild or an artisan type product. Large scale production of that is limited, and yes, we can sell it for money, but when we're thinking about what the industry is willing to pay us and what it's worth, that wool has very little value. And so wool really at this point has turned into more of a byproduct of raising sheep, unfortunately. And I hate to say that, because I'm a big fan of what is a renewable resource coming off of our sheep that are producing milk, meat, whatever. But really the difficulty is finding individuals that are willing to shear, can shear efficiently in large batches or numbers, and those are just very difficult to come by. So it's costing me more to take the fiber off, take that wool off, than it is what I'm getting return out of. And so that really is what classifies it as a byproduct, and the difficulty of selling it now is kind of gut wrenching, but that's just where we're at. So again, the facts you need to know when we're thinking about gestation: shorter gestation interval than our cattle. So we're right at 5 months, in that range. And these are twin bearing animals, or can be. It's not uncommon to have singles. It's not uncommon to have triplets. And certainly we have breeds of sheep that are what we would consider litter bearing. So Finn sheep, Romanovs, there are individuals that have selected to raise sheep that have 4, 5, 6, 7 lambs. That's personal opinion, more work than what I would like to invest into raising sheep, because the likelihood of that you being able to feed those to a weaning weight is unlikely. But really the advantage we have from a sheep standpoint is twin bearing. We can produce 2 lambs for every 1 ewe that we're raising. And then they're efficient grazers, and that really offers opportunity for these livestock diversification opportunities. So if I have cattle, there was a paper that came out, I believe, in the 80s, and nobody has debunked it to this date. I believe it's in Montana. They had, at a research station, had a large herd of cattle, and they also had sheep. And one year they started to analyze, when they combine the sheep with the cattle, what type of impact do we see in stocking rate, forage production. And what they fell on or landed on was they can produce 1 ewe or graze 1 ewe for every 1 cow without changing stocking density and stocking rate. So if I have 100 cows, the data shows us we can raise 100 sheep on the same number of acres with the same forage, because our grazing behavior is quite a bit different. And so again, when we're thinking about diversification, I think to me that makes a lot of sense. Certainly there are items that come along with that are more labor intensive. So with that lamb, that sheep being smaller, they're producing a smaller offspring. And so that lamb at birth is more susceptible to hypothermia, predators, because of its size than what a calf would be. So again, being the sheep individual, you're going to hear more sheep stuff. So I apologize, but try to be a sponge and absorb all of this. So when we're thinking about the product we're producing, and that is lamb, that's what we're getting paid for here in the U.S., 60 to 70% of the lamb that we consume in the U.S. currently is imported. To me, that is a staggering number. It means that, in my role and my feeling, we have to increase U.S. lamb production if we are going to remain relevant as a U.S.-based industry, being the American sheep industry. If that wasn't bad enough, we are looking at, or we are not, but the UK is looking at importing additional product to capture the demand that the US has done a really good job at cultivating. And their goal is to capture about $45 million across the next 5 years. And this is going to impact both traditional and non-traditional markets. And when we're thinking about non-traditional markets, so our lighter weight, ethnic lamb, with our diverse cultural background, especially in Pennsylvania. And the reason I bring this up is because in Pennsylvania, we have one of the strongest lamb markets in the U.S. So market in general, and then market specific to New Holland, Pennsylvania. There's a number of sheep that are marketed through that entity, and very, very popular across the U.S. of sheep that are getting trucked into Pennsylvania for sale. On top of that, the reason for the demand at that individual market is the urban hubs, or those cultural kind of epicenters that we have just a stone's throw away from our border, and then also southeastern Pennsylvania. So Philadelphia, certainly, DC, New York, of course, Boston, all of those items really make Pennsylvania a integral part to, or what could be an integral part to, marketing lamb to clientele that enjoy eating lamb, enjoy consuming lamb, and the only way we're going to capture that is if we improve and increase production. So why sheep? Again, we talked about grazing behavior, and they're different than our other livestock species. Certainly with the clean energy push and what we're seeing in solar development, not only in Pennsylvania, but across the U.S., sheep could be a big ticket item, and the reason we're going to spend, it's not just out of passion of myself, but chances are you will hear more about this, and in terms of livestock that has the most opportunity for growth in the next 10 to 15 years, this is where we're going to fall with that. And so when we're thinking about vegetation management under these panels, we're already pushing for green energy, or these corporations are pushing for green energy. And so when, as a grazer, if I'm pushing for a more sustainable approach to managing vegetation to companies that are already committed to it, a green on green thought process or pitch to these companies makes a lot of sense. And so if I can manage the vegetation for that company and do it with my sheep off farm, there is a lot of opportunity for economic growth for both the producer and then industry growth for the sheep industry. And we're going to see if this video plays, just an example of why they fit in that grazing system and what the differences are. So that weed that she is consuming be mare's tail in a field of forage soybeans. And those forage soybeans would have a high level of palatability, digestibility, and she's gone straight for the wheat in this setting. There's some other sheep in the background that are also consuming those less desirable forages, at least to what our opinion of less desirable forages would be. And that's why really when we integrate them into our kind of mixed species grazing, they work very nicely. So certainly we're going to talk about pigs. We've got a lot of pigs in the state of Pennsylvania, certainly neighboring states like Ohio. Think about gestation, 3 months, 3 weeks, 3 days. It's a fun one to remember and an easy thing to remember. If that doesn't work for you, 114 days is what that gestation interval would be. And so the shortest of our larger livestock species, most of our swine in the state and in the Midwest would be considered intensively managed. So because they are monogastrics, that next bullet point, meaning they possess a digestive tract similar to what yours and mine would be. They have a single compartment of that stomach responsible for the chemical digestion and breakdown of that feed stuff. Because of that, a large portion of their diet, or I could probably say all of their diet, is coming from corn and soybean meal. And those things are complementary to each other with what that animal needs for what that pig needs. And there's very little value then in a larger scale production oriented system. There's very little value to putting these animals outside. And I say that because chances are you will run into some pasture based swine production or pork production. And when we think about, is it possible? Yes, certainly. And there's improved practice to be done in that field. But when it comes back down to efficiency of production, the confinement model and what we've viewed as vertically integrated makes a lot of sense from corporations that have implemented that, from the family farm that backs those corporations or is the scaffolding that allows for that vertical integration. We're looking at raising those pigs in confinement from day 0 until slaughter date or for the rest of their life. And that, is a human, or if we're going to put anthropomorphism on it, could be viewed as a negative. When we think of an animal welfare standpoint, I tend to think it's a more positive method of production. And certainly when we think about maximizing productivity and efficiencies, this is where we land, and this is where we've landed as an industry as a whole. So, on that front, vertically integration, all that's to say, or what that means, we have growers or those that are producing that piglet, that young animal, and that same company or same family will raise that animal from that point to slaughter, and then from slaughter into the marketing chain. We see a lot more uniformity or continuity through animal ownership on all of those aspects of production. So then just a brief slide on concerns with livestock. So certainly nutrient management, again, I think you're going to hear about that today. That's a big one. From a manure application standpoint, we have a lot of grazing livestock in the state of Pennsylvania. And when we're thinking about manure management or nutrient management, a lot of the thought process is, well, they're out on grass. So, those nutrients are being recycled, and I don't have a lagoon or a manure pit. So I don't need to be concerned about it. And however, that's not the case. It's something we at least need to be aware about and plan for and have a plan in place for that. Environmental impact. Certainly, we catch a lot of flack on the livestock side of things, probably more so than other agronomic entities. Is it perceived? I would tell you yes. The majority of it is. When we're thinking about methane production and greenhouse gases, we're sequestering a lot of carbon in our agricultural entities, and certainly livestock are a large part of that. The next big thing with livestock is accessibility, and that comes back to the producer. So less the actual animal, but cost of production. Can I be profitable? Can this be a business? And what things need to change so that I can turn it into that as a livestock producer? And then marketing, and that goes back into the profitability standpoint. I think we struggle a lot of times as producers to market our own product because we're so busy raising that quality product that we forget to actually sell it. And when I say sell it, I mean really push it and highlight the improved aspects of the product we have to offer. But with that, I will certainly take any questions, comments, whatever.
I was just gonna say something and then I saw Paul starting to talk, so I'm not sure.
Either one, we'll take them.
No, I just was gonna tell folks that if they have questions that pop up, you can drop them in the chat too. Maybe Cameron can just linger for a couple of minutes in case anything comes up in your mind. And at the moment, there's nothing there. So we thank you, Cameron, for a great presentation. And
yeah, and certainly, if you have questions that come up, I guess I should add a contact slide in here. But if you have questions that come up later, certainly you can find me on that Penn State website. My email is clm6630@psu.edu, and certainly can either answer that question or direct you into someone that can there on our Extension Livestock team.
Great. Well, thank you very much for that.
Yes.
We really appreciate it. And
Great. Well, you guys have a good day, and I appreciate your flexibility.
Yep.
This seems like a fun thing. So you guys have a good one, and I appreciate the flexibility and a good audience.
Yep, you got it. Have a wonderful rest of your day. And with that, we are going to roll right into our next speaker, who is Dr. Rob Minen, who is going to be giving us a rundown on biosecurity, which is going to be really important for us when we get together in person in a couple of weeks.
Thanks, Jen. Can you see my slide?
You got your slides. We can see. Yep, there you go. Perfect.
Sweet. Okay, I just popped a website address into the chat, which I'm going to recommend people can visit to learn more about biosecurity. I also just appreciate all the things Cam said, because Cameron does a great job, and that was a really nice overview of some animal industries. So that biosecurity link I put in there is one that I recommend, and I'm going to get to it at the end of my presentation. But some people do like to browse while they're listening to to somebody speak over the computer, Teams or Zoom. And if you want to look at that website now, feel free to explore it a little bit, because it's really got great information, and a lot of the information I'm going to talk about is there. So I want to look at biosecurity for on-farm visitors. My name is Rob Minen. I think my contact information is there at the bottom of this slide, and we can pop that into the chat at the end if we wish as well. The history for myself is that I have a swine management background and have been at Penn State for over 20 years. I am the director of the Nutrient Management Education Program, so I've worked quite a bit with this area between animal agriculture and air and water quality. But the background I have as a swine producer was at a swine multiplier, meaning we were raising female hogs or gilts that would become breeding stock at other farms. So we had 45 other farms that were relying on us to supply them with breeding stock. And that was very important that we have great biosecurity, because any hiccup in our herd health program could cause a loss of production and for us to slow down. And so that's important for all the people we were supplying pigs to. And any farm, it becomes very important. So imagine if I did an action in your area of work, and whether it was intentional or not, it cost you $1,000 out of your pocket. You probably wouldn't be very happy, right? And that's what biosecurity could be like. Whenever I was managing hogs, myself and the people that worked for me, there were 5 of us at the farm, we all had a bonus system. And our bonus system was based on efficiencies of production and also getting the right number of animals per quarter. So every 4 months we could get paid a bonus if we met our targets and did it in an efficient manner. Well, challenges in herd health can really wreck that. So my bonus doesn't come this quarter, and if that's because of somebody bringing a disease, an infectious agent into our farm, that really can impact me. So that's something to keep in mind. It's very important to everybody who works in the industry, as well as the products and the welfare of the animals. So the swine industry and poultry industry on this slide are certainly the highlights of where biosecurity is really enforced with a stringent manner, and the biosecurity becomes more and more strict and more followed, by the producers as time goes on. It's very hard to get into a swine or poultry barn at this point because of biosecurity threats. The industries, as Cam mentioned, that are vertically integrated have kind of just shut down visitation. So if you're working with a swine or poultry farm, you likely will not get very close to the animals or in that barn. So that is something that in expectation of, I'm going to go to the swine farm or the poultry farm and get in the barn and see the animals, that may not happen. The cattle industries, the dairy industries have been a little more lax with biosecurity, and for understandable reasons, the health challenges there are a bit different. I'm not going to go into a lot of disease specifics today, but just brought up another slide here on HPAI, highly pathogenic avian influenza, which is a concern ongoing for the past couple years. And I have 2 graphs here. These are from the USDA website on HPAI. And the first one I have circled in red is from February. This other one is just from yesterday. So these are just maps and year-to-date confirmed flocks. And you can see in the first graphic, we have 763 confirmed flocks of HPAI across the country by mid-February. That has climbed a little bit, but has greatly slowed down as February waned. And it highlights the importance of seasonality with this. HPAI can be spread to commercial flocks with the migratory birds that can carry this disease, avian influenza. And it's just one of the current diseases that we're really battling. And we fear that when the migration starts again this fall, that we might see a spread. And little box on top, the Conservation Commission, Department of Agriculture, the state veterinarian may suspend farm visits for people such as plan writers or conservation personnel if avian influenza kicks back up. And that has been done at times in recent history. If anybody has questions as we go, feel free to pop in and ask them at any point. Be happy to handle it that way, or we can wait till the end. So biosecurity, I've been talking about it in the context of animal agriculture. It's a series of management steps taken to prevent the introduction of an infectious agent or into a herd or flock. These steps don't have to be complicated to work effectively, but they do need to make the biological sense. So I've mentioned that violating biosecurity can mean losses of production and even losses of animal life. So it's a welfare issue as well as a dollar issue and an efficiency issue for the farm. It does require that you ask some questions before you get to the farm. So you should know the producer's protocol and follow that protocol before you get there. And a lot of what we'll talk about as we follow will involve protocols that you should consider. So here's just a list. I'll just run through this real quick, right? How do we transfer bacteria and viruses, disease sources, right? We can transfer them with manure, urine, air, eye discharges, nasal discharges, through milk, blood, saliva, semen, uterine fluids, fetal tissues or membranes, and then tissues discharged from live or dead animals. So these are all things that if we come in contact with them and we move from one farm to another, we need to be aware that contact at one farm could lead to transfer of disease to another farm. So this direct contact, which I mentioned, is a way to make yourself a fomite. What's a fomite? A fomite is just an object, if you will, that carries and can transfer bacteria or viruses, spread a disease. And this can include yourself, the animals, equipment, feed, water, vectors of rodents such as or nuisance animals such as birds, rodents, and flies. And it can also, a fomite can be the air, if you want to think of a disease transfer that can go out of a fan of a barn and toward animals in another barn. Biosecurity, as mentioned, is a series of management steps. It's how we behave on a farm and how we manage the people and the equipment and the things that come and go on the farm to prevent that introduction of a disease. Well, one form of biosecurity can be structural in nature. These would be barriers, right? These are physical objects which prevent us from transferring disease. And a simple example of that would just be a door, right? If there's a door that's shut, I shouldn't go in there, especially if there's animals on the other side of that door. That has to be something that management directs us to do. Operational biosecurity are the practices, policies, and procedures that are consistently followed by people. So understand the operational biosecurity systems before you go to a farm to visit them. Part of this operational and structural idea can include what we call lines of separation. So this can be a visible or an invisible line, right? This is just an area that you do not cross, right? You should not enter and cross that line of separation because management of the farm is trying to keep the animals within a boundary separate from anything outside of that. So we want to treat that as a wall and not cross that. The goal is to keep yourself separate, and that can be different for each farm. Here in the bottom, we have 3 photos. The first one is just at the end of a ramp, a loadout chute, and we have a trailer. That orange tape was put on there to help show us that in the arrow, here is the line, that if we were loading animals out of that barn and someone came with a trailer to take the animals away, we wouldn't step on the trailer as an employee of the barn. We would hand the animals off, they would cross that orange line, and then the other person would take care of them from there, and we would not step on that trailer because we don't really know where that trailer has been or the animals that were in that trailer last, if they had a disease or not, and we don't want to bring anything from that trailer back onto that ramp and into our barn. There's a simple showing of a rubber boot, right? Rubber is a really good way to go to help us be cleanly as we go from farm to farm and spot to spot, and they're dipping their clean boots into a disinfectant solution. Important on this line of separation idea is also this bottom picture. Here we have 6 swine houses at one farm, aerial view, and the physical barrier inside of each one of those barns is designated with the red, right? The red square I have drawn there represents that physical barrier with the door, etc., and we may never go in as if we're working with that farm. The yellow line might represent a different idea of a barrier where that line of separation, we might not cross that. Or another idea with this farm is you can see a lane coming in from the left and a lane coming in from the right. Maybe employees come in from the left and the manure hauler and other people that are dealing with different aspects of the farm come in from the right. They come in from different directions so that their tires and are not crossing, etc. And that can be highlighted with this photo. I took this photo several years ago in Lebanon County. and it was late winter, early spring. And in the background, you can see a large layer facility. So there's perhaps 1 million laying hens in that barn. And what you see in the foreground is not snow, there's actually a large flock of snow geese. So as I mentioned, this HPAI, the highly pathogenic avian influenza, can be transferred by migratory birds. So if this flock landed here and one of those birds shat out some manure that had avian influenza virus with it, and we were working in that field and we drove through that and went over to the barn and crossed the place where our tire went across the footpath where an employee coming in to sort eggs or work in the barn came in and walked across our tire tracks, they could transfer that disease from the field, from the goose, the snow goose, to our tire, to the driveway, to their boot, into the barn, right? So that type of connection can easily happen in reality, but that helps highlight the line of separation. If we were working that farm, we would want to enter and drive in a spot that does not cross traffic with other important people, especially people that enter the barn. Farmers should know this, right? So you want to ask about biosecurity protocols before you get to a farm. So you're a professional visitor. What are your responsibilities? I have 3 ideas here, right? First, you need to, as a professional, be knowledgeable and act as an educator, right? Be knowledgeable about disease and prevention procedures, right? Serve as an information resource. We appreciate that not everybody in this in boot camp is a livestock expert, right? That's okay, but you do need to be knowledgeable and follow protocols. You also want to be a role model, right? You want to walk the walk as well as talk the talk. And you do not want the finger pointed at you if a disease outbreak should occur. You would rather have the producer that reflects back and says, oh, I have a disease challenge. Who visited my farm? What happened? And if they say, well, that person came from the agency or the district or wherever you're working, and they didn't follow biosecurity, and I know that they also visited another farm with the same species a day before, then they may suspect that you are the one transferring disease, and you really don't want that. That doesn't do anything good professionally for you or for your organization. And then you also want to be a supporter of this and take initiatives to learn the biosecurity protocol for the farm that you're visiting and then willingly follow and participate in their guidelines. Here are 2 important things that helps break the spread of disease. One, we just call downtime, if you're not familiar with that. All that means is it's a time that you're away from animals. I mentioned I manage swine. Our veterinarian and our service person always visited us on a Monday. That way, they could have 72 hours of downtime, meaning they were not around any other pigs for Friday, Saturday, or Sunday before they came to our farm. That gave us an extra level of time that if they were carrying a bacteria or virus with them when they visited the last farm they were at, the last swine farm, their downtime would help to inactivate and minimize risk of them bringing something into our farm. Our feed trucks also all came on a Monday. So that's how we managed. I mean, we had to manage and order feed for a week at a time so that we knew that the trucks themselves would often have downtime. Exposure is another thing, right? If you have exposure that you know of, you need to really be cautious, but you need to also think that you're always going to have exposure. You need to always suspect that you could be exposed to a disease, and that means you're going to clean and disinfect, follow protocols, pre-plan your movement based on animal health status if necessary or when appropriate. What do we clean with, right? Cleaning and disinfecting is very simple. The basis of it is that you want to remove organic matter, right? The organic matter is going to have a high risk of carrying any infectious agent with it. Once we remove organic matter through scrubbing with cleaning materials and soaps and water if necessary. Then we want to disinfect and clean the surfaces. Disinfectant products should be used according to label, right? More is not always better. Sometimes it's just more. So you just need to follow the labels and do as they say. When you visit the farm, right, plan your farm visit. Make the appointment, talk to farm management, understand what their protocol is. Try to limit yourself to one farm visit per day if you can, because multiple farm visits decreases significantly your downtime, right? If you go from one farm to the farm next door, you won't have very much downtime, and that increases risk. You want to talk to the farmer about the guidelines, right? Do they have downtime? Do they have spots where you need to wash your tires or any part of your vehicle before you come? Ask where you park. Parking is a biosecurity concern, but it's also a social item as well. You don't want to park where the milk trucks need to turn around, right? You don't want to park where feed trucks need to enter. You don't want to park where employees are crossing. So ask, where should I park? And they will appreciate that. If you need to enter a facility, make sure you have that cleared with the farmer ahead of time, but you want to know in the second last bullet there where to meet the farmer. They may not want to meet you in the facility at all. They might want to meet you somewhere outside, and that's great. Think about clothing and footwear that you should wear, and ask if there's anything special. Explain that you're willing to bring rubber boots and plastic booties if you want, Tyvek suits, etc. We'll go over those in a minute, and ask what they require. PPE, right? So this is the personal protective equipment. These are the things that you can buy and transfer around with you in your trunk, or you're behind your seat of your truck, whatever it is. And these would include disposable booties, coveralls, face mask, hairnet, disposable gloves. The booties and coveralls would probably be the most common ones that we would run into a need for. You also would like to travel with a bucket, a brush, and disinfectant, right? Maybe also, I don't have it here, but a gallon of water, a jug of water, so that you can mix things up with the disinfectant as needed, or maybe you pre-mix it. You might also want to have a little bit of soap, dish soap or some other kind of soap that you could put with the water to scrub off organic matter. Throw a clean garbage bag in with that kit. And whenever you leave a farm, you take your booties, your PPE off, put it in that garbage bag. Ask if you can leave that bag with them. That way the farm knows that your dirty clothes that from their farm stay at their farm, and you're not taking things from one farm to another. So you want to develop some kind of kit, if you will, and you get yourself a tub, like a Rubbermaid type of a tub or something to keep these things in, and then you have it ready to go at any time. And this would include items such as clothing, which are clean, coveralls might be an option there, rubber boots or disposable plastic boots. If you're going to make a lot of farm visits, you might want to have rubber boots and then clean those off before you take them away from the farm. Foot wash material, I mentioned that, which would include the bucket, the tub, boot brush, disinfectant, soap, water supply, trash bags, and then hand care. We could include disposable gloves and sanitizer. When you arrive at a farm, make sure your vehicle is adequately clean. If particularly mud and manure from previous farm visits should be removed. Some farms, when you enter them, would have a tire wash, particularly poultry farms or some sow farms in the swine industry that you may visit. You want to be aware of where you park. We've mentioned that. You want to consider safety as well as considering the traffic at the farm. Don't drive through facilities or livestock traffic areas, right? We want to try to avoid driving around if we can. Respect all warning signs, and then meet the farmer at a low-risk area. Again, we want to talk to the producer before we get there and ask, where do we want to meet? Also, have their phone number handy. Make sure you have that with you so that when you get to the farm, you might have to call and say, hey, I'm here. I'm ready to meet. So you want to put your when you arrive at the farm, right? You step out of your car. First thing you want to do is put on your clothing and footwear to meet the biosecurity protocol, right? Those rubber boots, those plastic boots, those coveralls that we've talked about. Often we need to carry other materials with us, right? Some items, paper, notepads, computer, sampling equipment, etc., right? Make sure those are free of organic matter. Make sure they're clean, disinfected if necessary, if they've been to other farms, and if appropriate, you don't want to, dunk your computer in liquid, but you can spray it down with some Textrol or some other product. If your equipment has been in contact with animals, feed, or manure, other organic material from any farm, you want to especially be careful that you remove that organic matter and disinfect. During your farm visit, do not enter facilities unnecessarily. Make sure as you enter a facility that you're doing it with the management or under the permission of the management. Minimize animal contact or avoid all animal contact if you can. Avoid walking through high-risk areas. What are high-risk areas? These are areas that are going to have organic matter, right? The areas with manure, feed areas, that we might pick up something that we transfer within the farm from animal to animal or to another farm. We want to think about going from clean to dirty. So if you were going to go into a farm and evaluate an entire farm, you might want to start with a clean part, which would be where the animals are, and then manure processing area, instead of starting at the manure processing area and working into the animals. For example, manure processing areas and handling areas could have flies and birds that are there that brought in a disease, and you don't want to track that from the outside of the barn to the inside. If a farm has multiple animal groups, this is very common whenever we have growing animals, or there's some of our photos here with cattle and especially with dairy, where we have the calves and heifers and milking cows all in one facility. If possible, you want to start with the young animals and move to the adults. So start with the young, move to the old. Start with the healthy, move to the sick. If the producer has other protocols that he wants you to follow or she wants you to follow, then you can do that, but do not be afraid to make suggestions. It's very easy for a producer to think of you as an expert and as an agency person that is going to tell them what to do. And if they're trying to work within that system and not understand where you're coming from, it's okay to say, well, how about if would it make more sense if we go from the young animals to the old? Finally, on the bottom large bullet there, if we have multiple farm visits in one day, we are at a higher risk, right? So you would want to go from a lower risk farm to the higher risk farm if you have to do that. If some farms you visit have mixed species, you need to consider that, right? If you have a poultry house and a dairy on the same farm, you probably want to go to the poultry house first, then to the dairy, because the poultry may be considered a higher risk. Communicate with everybody on how you're going to do this and work with the producers. When you leave the farm, make sure you wash and disinfect your rubber boots. Remove all that organic matter. We have said that several times. If you have plastic boots instead of rubber boots, place them in a trash bag and leave them at the farm if the farmer agrees to that. If they don't want them, you can put them in your vehicle and dispose of them properly later. Wash your hands, sanitize, and then clean your vehicle for the next farm visit. How do you choose a disinfectant? There's no perfect disinfectant, right? Follow criteria when selecting disinfectant, and these criteria can also be found on the website that I recommended and will recommend again. Effectiveness against pathogens, effectiveness against organic matter, removal of dirt and soil and manure, exposure, potential damage to clothing and equipment might be considered, right? If you're going to use bleach, you don't want that on some of your clothing. And then also expense. You can go from bleach, which just costs you pennies, to very expensive disinfectants. Many disinfectants are inactivated by organic material. So remember, organic material needs to be removed before we can disinfect. Many commercial products require extended time of exposure, which is not very practical. So you want to also get a quick acting or something that you expect will work within your time limit. I have a bullet here, allow surfaces to dry thoroughly. For instance, when you leave the farm and you scrub your boots down and disinfect them, you want to allow them to dry before you go to the next farm. And getting boots clean is very important. Here's a list from this website I recommended. So this is the chart. I'm not going to dive into this at all, but it gives you some strengths and weaknesses for different categories of disinfectants. This website is called Healthy Farms, Healthy Agriculture. It's run by the University of Vermont. It's a really nice site. If you haven't already looked at it, bookmark that or something, because it's a great place to learn. So again, here's a screenshot of their front page at the Healthy Farm, Healthy Agricultural website. And I find it quite intuitive and quite easy to learn things from whenever I go to that website. Of course, Penn State has biosecurity items. You can go to Penn State Extension and search the word biosecurity and come up with some really good things. And another resource I recommend is National Agricultural Biosecurity Center, run out of Kansas State. So in conclusion, biosecurity is fairly common sense stuff, right? Removal of organic matter is very important. Always communicate with the producer. Always make sure everybody knows all the protocols and how we should act. Understand those lines of separation. The key to biosecurity practices is making it part of your routine when you visit a farm, and should become a habit, like washing your hands for dinner. So I think that wraps me up. If anybody has questions, I'll be glad to talk.
Yeah, excuse me. Yeah, Rob, it looks like there's a question from Carly. To clarify, you recommend
Okay.
visiting poultry, to clarify, you recommend visiting poultry facilities before dairy, starting with high risk. That seems to go against what you recommend. Could you clarify that?
Okay, well, the higher risk animal in that scenario would be the chicken, right? That we would have a higher risk of introducing something to the poultry animals than to the dairy cows. So given the choice in that scenario, it's less likely if we go from the chickens to the cow that we take a disease from the chickens to the cow than it is that if we go from the cow to the chicken, we could take a disease that we pick up during the cattle visit or dairy visit to the chicken, if that makes sense. For instance, we're walking around the manure storage at the dairy farm and a bird has been there and sheds avian influenza, and we go into the poultry farm. So I hope that makes sense.
Does that make sense there, Carly? Okay. All right. Well, thank you, Rob. I think our next presenter will be, oh wait, we have another question. Sorry. If an operation is crop only, but they spread manure, what would be the biosecurity considerations?
Oh, great consideration. We deal with this quite a bit, you know, in my world with transporting manure around. The biosecurity there is going to be different, because if they don't have animals, then the risk of transferring something to their animals is low because they don't have it, right? It's zero. It doesn't exist. But if you leave that farm, if you're at that facility and you're in the field or you're in the area where they've stacked manure or have transported it, then you should consider yourself a risk, right? Because if you go down the road with organic matter from that farm, from their fields or their stack pads, then you are now traveling risk. And wherever you go, you could shed that virus from your vehicle yourself. So you just need to be careful about that anytime you're in a field. Cam talked a lot about pastures, right? Pastures would be another area where you might not think of it as a high risk, but we should be thinking about those things. And the risk might be different, right? It might be lower, but it's still a risk. You know, there's stop signs in everybody's neighborhood that are more dangerous than others, but you should stop at every stop sign and take a look before you go through any intersection.
All right. All right. Any other questions for Rob before we let him go?
All right. Thanks, everybody. I know you're late behind schedule, but I started a little late, right? So I will let you carry on. Thank you so much.
Sure thing. Thanks, Rob. Next up, we have Katie Brooks, another Penn State Cooperative Extension educator. Katie, if you'd give a quick introduction for yourself, that'd be great.
Yeah, so I'm Katie Brooks, and I'm a forestry and wildlife educator with Penn State Extension, and I'm based in McKean County, which is north central PA, but I cover a lot of area and even across the state if needed. I will share my screen, and I hope everyone can bear with me because I've never shared in Teams before. I typically use Zoom, so. Okay, is everyone seeing my PowerPoint? Does it look good?
Yes.
Okay, perfect. So again, this is my intro slide and myself. And it has my address, phone number, email address there if you want to get in contact with me later, have any questions. And then just some of the areas of interest that I typically cover within Extension include wildlife, habitat management, invasive species, and also youth education. And fortunately, I think my PowerPoint is a little bit shorter than what is scheduled for, so I should get you out hopefully a little bit early and get you to lunch on time. But today I'm here to talk about just an introduction to fish and wildlife. So the objectives for my talk today are to talk about why fish and wildlife need to be considered in conservation planning, understand the resource concerns that are of importance when we're talking about wildlife, and then begin to look at the viewpoint of the agricultural landscape and see the different systems that can work together and complement each other. So that being agriculture and wildlife habitat. So obviously wildlife has value, but its value varies depending on an individual's viewpoint. So for me in particular, I would obviously place the value on wildlife very high. That's, part of my career has been based in wildlife. My undergrad was in wildlife. So for me, that has very high value, but for some people it doesn't. And so while it all does have value, it's different for every person. Just like any resource, it just depends on our viewpoint of that resource. And so why should we even think about wildlife on a farm if it's not one of the farmer's objectives, if it's not something that our farmers have high value on? Why are we even talking about it? And the reason the answer to that, the reason we have to consider wildlife is because it's a public resource. So it's the same as air or water. And we consider wildlife a public resource because of the history of our country. So I'm just going to cover that quickly to give you a little background on why we're even talking about this. So in Europe, before the colonization of North America, the British model of wildlife ownership said that the land, crops, livestock, trees, and wild game were property of the landowner and really were property of the king. The king had the ability to even take those things away from the landowner if they so desired. Only the landowner or the king could grant rights to hunting, could grant rights to land or fishing. And the king could even gift these rights to individuals that other than the landowner. So like I said, he could take those rights away from the landowner and give them to someone else. So in essence, the king, one person, managed all natural resources and wildlife for the people and remained the only one to own the rights to do that. And unauthorized use of any of those items, any of the land, crops, wild game, trees, anything was a punishable crime in Europe. Later on, North America, we decided to handle wildlife ownership much differently than in Britain. So in our case, there was no monarch to own all of the land and all the natural resources that lived on it. At first, when North America was colonized, there was kind of a take what we want mindset with settlers that later shifted to kind of a good for all mentality. Once we started to see the impacts of that, like take mentality, we saw the impacts of it, and we lost some of our species. We kind of developed this mindset that we wanted the wildlife and the resources to be used for the good of everyone. So now in North America, wildlife is held in public trust, and this is known as the North American model of wildlife conservation. So it's a publicly owned resource, public property, and these resources are managed by the state. And so this is just a section of the Pennsylvania Constitution, Article 1, Section 27. It's also called the Environmental Rights Amendment. And this specifically says that natural resources are the common property of all the people, including generations yet to come. The Commonwealth shall conserve and maintain them for the benefit of all people. And in Pennsylvania specifically, public wildlife resources are managed by the PA Game Commission and the PA Fish and Boat Commission. So as a result, we have laws that oversee fish and wildlife as a public resource, which state and federal agencies must always consider, not just when it's a farmer's or cooperator's choice. Some of these laws are the National Environmental Policy Act, the Water Pollution Control Act, Clean Water Act, Endangered Species Act. These all state how fish and wildlife must be conserved as a public resource. And I'm not too familiar with a lot of the NRCS programs, the specifics of them, but I do know that on the there's an environmental evaluation worksheet, and I believe there's places to inventory and address wildlife that include threatened and endangered species as well as migratory birds. And so within all of that, when you're planning to do different conservation practices, you have to consider aquatic and terrestrial wildlife habitat because of these different laws. So sometimes the landowner and the laws may not have the same objective. A pretty good example is when we talk about manure. So in this example, a farmer says that they need to spread manure in winter because their pit is full. But in the law, it says you can't spread manure at certain times because we're trying to protect water quality, and we're protecting water quality because it has public benefits for clean water for everyone. Another example would be wetlands. Historically, we did often drain wetlands to get more land to use to graze or for crops. And then laws were created to protect wetland functions because there are public benefits of wetlands for water quality, infiltration, and flood control. And so there are times when the public benefits and the public resources outweigh what an individual landowner might think is best for them. So, like I said, that all just boils down to we have to consider wildlife because it's a public resource, just like water and air. Fish and wildlife are part of those resources that are publicly owned. So getting more specific into farmland wildlife in particular, it doesn't include every species of wildlife in Pennsylvania, but it does include those species we see a lot on farmland. And so those would typically be our species that are adapted to live in non-forest areas, grassland species, and then even some of our edge species that prefer to live in between forest and grassland, and our edge specialists. These are really important, these farmland wildlife species, because they include some of the fastest declining species. So for example, grassland birds have seen a 60% decline over the last 40 years. And so they're really something that, nationally we're keeping an eye on because of the decline. So there are many reasons why farmland wildlife might be declining, and they can be broken down into two groups, natural and unnatural, or man-made occurrences. So predators and disease are natural occurrences. So historically, wolves and mountain lions would have been major predators in Pennsylvania, but now we have coyotes, foxes, birds of prey that are natural predators, as well as humans to some extent. For some species, we could include ourselves in predators. Diseases are also natural control, things like chronic wasting disease when we talk about deer, and avian influenza that we just heard about for birds. These predators and disease are natural, always commonly occurring things that decrease or control wildlife populations. But they're controlling them not in an uncontrollable way, I should say. They're not reducing the populations for the most part to an extent that we're concerned about the natural declines. When we talk about unnatural occurrences, this is the large-scale habitat loss and use of pesticides. So a great example for pesticides, I'm sure everyone's heard about bald eagles. They declined in the 1960s from the use of DDT. They were poisoned when they ate contaminated fish, and then it didn't actually kill the eagles, but it affected their ability to reproduce. So they couldn't produce strong eggshells. And then as a result, their eggs had shells so thin that they broke during incubation and failed to hatch. So the pesticide DDT was banned, and it helped the eagle population to rebound. So that's a really, classic example of an unnatural decline in wildlife populations. Also, and we'll talk about this more a little bit, but land clearing and development is a huge part of large scale habitat loss and a major reason why we would see that type of unnatural decline. So when we talk about predators, there's if you take any biology or ecology classes, there's a syndrome that's often taught called Hawks and Foxes syndrome. This is just an example of a predator-prey relationship. This is a cycle where populations go up and down naturally. Prey species may decline for some reason, like a normal disease outbreak or a lack of food due to bad weather for a year. And then we see a tailing effect maybe the next year or 2 years later of a decline in predator populations due to that decline in prey populations. But then as prey species rebound and their populations increase, predator populations will have a tailing increase as well. So this is a directly related relationship. The predation on prey species is normal and won't cause a decline in prey species unless there's something else wrong. So something like loss of habitat, a new or novel disease that they don't have any ability to fight off, just something else that is causing a compounding effect of decline. And another thing to remember is that predators are wildlife too. They may even be prey for other predator species. So a small predator, may be eaten by a larger predator. So then we also talk about diseases with the natural decline. These are things like rabies, avian influenza, chronic wasting disease, West Nile virus. Unlike domestic animals, wildlife has more natural tolerance or immunity to these diseases, and there's less effect on wildlife populations than is commonly believed when we are talking about diseases. When we have disease on farms, we see an issue with things like poultry flocks and avian influenza, and it affects most or all of the birds because they're in one small area. But in most cases for wildlife, they're more dispersed, so there's less transmission and in turn less decline as a result of diseases introduced to wildlife populations. And again, most wildlife is going to have some kind of natural tolerance or immunity, more so than animals that we see on farms. So when we think about something like rabies, there's positive reports of rabies all the time, everywhere, but it doesn't cause any widespread population decline. So it's always there in wildlife populations, but it's not causing significant decreases in the numbers of wildlife that we're seeing. So we're going to start then talking about some of the unnatural reasons or unnatural causes of population decline. So starting with pesticides, typically pesticides are not directly killing wildlife, but they're affecting the plants or insects that wildlife is feeding on. So pesticides kill plants or insects, which it first reduces food resources, so less food available, just by the fact that we're killing a food source. And then also, in some cases, pesticides absorb into plants or insects and transfer to other animals that eat that affected pest. And we can see some effects whenever we start talking about bioaccumulation. And so that's where kind of what I talked about with the eagles, where a prey or predator species is eating a prey that is contaminated with a pesticide, and then they're accumulating doses of that pesticide in their body, and that eventually causes an adverse effect. Something similar to this would be lead in waterfowl. So we don't use lead shot for waterfowl hunting anymore because they were seeing some bioaccumulation in predator species that were feeding on fish that came from water bodies where lead shot was accumulating. And they were seeing animals dying from lead poisoning due to that bioaccumulation. So that's kind of one example of how that can occur. But with pesticides, these issues aren't widespread typically, and they're very localized and affect just a few individuals at a time. And these issues with pesticides are reduced by using pesticides and herbicides in a way that's consistent with label instructions, following the regulations related to them, and just really monitoring how much of them we apply. And so what it really comes down to, the major reason for declining farmland wildlife is large-scale habitat loss. The other things are obviously concerns and do cause declines, but they're mostly manageable. And large-scale habitat loss is probably the number one reason why we're losing these different farmland wildlife species. So all wildlife, we obviously all know this, they need food, cover, and water, and they need all of three of these. Typically in Pennsylvania, water is readily available and not limiting, so we don't talk about that too much. I'm not going to cover that much in the coming slides because it's not a limiting factor typically in this area. But the important part about these resources is that they need to have all three available throughout the entire year. This is why we see some species that migrate. So birds and songbirds and birds of prey will migrate in the fall because their food sources decrease just due to the seasonality, obviously. So these birds go to places where food's ready available. For many of our bird species, they're going to the tropics. That's just food is more available there during the time when it's scarce in their range up here. And so then when food starts to become more available up here in the breeding and summering time, they start to migrate back. And it's not just food. Cover can be seasonally and available as well for some species. We think of trees losing their leaves, and that's, you know, a loss of cover for some species as well. But mainly when we're talking about migration, we're talking about food. So this is a chart of the different resources available throughout the seasons. On the bottom, you see winter, spring, summer, fall, and then back to winter again. And then on the left is just a relative abundance of that resource. And so I said earlier, water isn't a limiting factor in this area. You can see water, you know, stays above that 50 abundance, and it's relatively stable compared to the other resources. When you get into fall and winter, you can see food and cover decline, which is what causes species to move to get to a place where resources are available. And so this is why even when we're thinking about, you know, crop fields or something like that, even in the off season, there may be seasonal differences between, say, September, October, fall, and winter of what's available there when things start to decay. And so that's a loss of food and cover as well. So when we're talking about wildlife, vegetation, or what we call habitat, is the key. So this is the food and cover, and is protection from predation as well. A lot of our wildlife practices focus on habitat. So my personal background, I went to Penn State to get my undergrad in wildlife and fisheries science. And then as I finished my degree and was looking at careers out there, I really realized that most of the careers that have any wildlife management involved, they really focus on managing habitat. And because of that, I went back to school and got my master's in forestry to really be able to focus a little bit more on how I could help have an influence on wildlife through influencing their habitat. And so the one quote that I really like is that habitat isn't everything, it's the only thing. It's really the only part of wildlife that we have control over from a landowner, land manager, farmer perspective. It's really the only thing we can influence. Obviously, through hunting, we have some influence on wildlife populations, but it's much more impactful from the habitat side. If wildlife don't have habitat, they'll leave and move on elsewhere to find it. So how do we affect vegetation in farmland? What can we do on farmland to impact the vegetation and manage for wildlife and in the conservation practices that we use there? Some options are using crop rotation, will help with both food and cover. Residues for food and cover. Cover crops are a great way to add food and cover. And then practices like long-term vegetation, buffers, and also making sure that we have some interspersion or just breaking up fields into different smaller habitat areas is also really important when we're talking about cover. And so part of evaluating or looking at wildlife habitat includes looking at, the distance to cover. How far does a prey species have to go to find safety? How large a field is, and then where is there uninterrupted cover occurring that maybe wildlife could use to get food or shelter, things like that. So when we look at when we're looking at crop rotations, a more diverse rotation is always better for wildlife. The more number of different species, the better. And this is something I talk about a lot, not just when I'm talking about farmlands, but just in general when people ask, how can I increase wildlife habitat? Definitely diversity is key. It's the most important thing. There's not one species that relies solely on one habitat type or one food type, anything like that. So the more number of different species, the better. If there's cover crops, the more time there's cover on the ground, the better it is for wildlife. It increases the duration of cover, and that's also increased food available as well. And then talking about crop residues, which are important for soil health, obviously, and erosion. So it's something, a lot of farmers are always talking about or thinking about. It's also important for wildlife. So a lot of times, retaining some cover for winter, as well as, retaining it as a food source for animals that don't migrate or those that don't hibernate as well. That's a place that they can find food over winter. So a lot of grassland birds come through and forage on these low crop residues that are available when very little else is. And then there's also cover crops. They're great for all sorts of reasons. And they're also practices that we talk about a lot with farmers in the cropland system in general without talking about wildlife. But when we are thinking about wildlife, they provide food and cover again during a time of year that there isn't much. And so you can see between these two pictures, just the amount of food and safety. If you're a small mammal, you're obviously going to want to be in the right where you can hide from predators versus on the left. There's just a lot more opportunities when we think about using cover crops. And so the great thing about this is these are things that farmers are probably already thinking about and can just have an added benefit of wildlife habitat. Then there's food plots, other cropping activities. Food plots are a choice that people make because they're interested in wildlife. And so I talk a lot with people that aren't farmers that are interested in using food plots to add wildlife habitat and add, again, a diversity of plants for them. But they can be used as part of a conservation stewardship program or, just because people like to hunt or bird watch. Again, this goes back to maybe the farmer that you're working with does place high value on wildlife. And so this is something that's important to them outside of their farming activities. And so that might be something they want to implement, but also just adjusting cropping activities to delay harvest a little bit or not harvest anything at all for a portion of the field, harvest the majority, but leave a little bit of it. Maybe around a field border, so a field that borders a forest, so along the edge there. Something like that also provides food and habitat for wildlife and is just expanding some habitat that may already exist. So an example to kind of start thinking about this, especially what I talked about with diversity, I think lunch is coming up next. And so what would you choose for lunch if your options were, or sorry, food for all day? So you get a Pop-Tart for all day or eggs and toast for breakfast, and then a sub with turkey, all kinds of toppings, and then grilled chicken, potatoes, and broccoli for dinner. Which would you choose? I think most people are going to choose that second one. That's a fully rounded meal. Going to keep you full for the whole day, hopefully. Lots of different options in there, and which would benefit you more. So if you're talking about a human's daily food, you're getting more nutrients from that variety of food. When we talk about a human diet, we see that a more variety of foods is better. You go to the doctor, that's what they want to hear, that you're eating a well-balanced diet. And that's why human food pyramids, or I guess now they use a plate with different sections. They talk about eating a variety of foods, including fruits, vegetables, proteins, carbs, should all be part of our diet. And it's the same for wildlife. They need a variety of different things, and that variety benefits them more than just one singular food source. So that kind of leads us into talking about vegetation type. Perennial plants are going to offer more benefits than annual plants, especially when they're not just the regular crops. something that's more long term. And obviously, we're gonna always recommend native species over non-native species, and I'll talk about that more in a minute. But some things, some vegetation we can start thinking about. Warm season grasses are varieties in active growth late spring, then they go dormant in the fall. They provide a lot of benefits during their growing season. So like the different bunch grasses are really great for wildlife habitat, good places for them to move in between the bunches while feeding, looking for shelter, things like that. Oh, sorry about that. And then cool season grasses and legumes, we don't recommend them as much, but they can be an important source because they green up in the spring and then stay green into the fall. And so they're some of the first available food of it, some of the first food available for many species of wildlife. And so just to start thinking about the different vegetation types and not having just one if possible. So I said I'd talk about non-native plants. I know this is a little bit outside of the realm of farming, but I do like to include this slide because I just think this information is really cool. But there's been some study done of that about, or the study came about because birders were starting to see that a third of yellow-shafted flickers, which are a pretty common type of woodpecker, were spotted with red and orange plumage, which is different than their typical color, yellow, obviously. And originally they, started to think it was maybe hybridization with a different species of flickers that have red coloration. But then a new hypothesis that the red color was caused by a pigment found in the berries of invasive honeysuckle shrubs. So Tartarian and Morrow's honeysuckle were found to have this red pigment called rhodonxanthin, and that when these flickers and also cedar waxwings, which are in this picture here, these pictures here, when they were eating these berries, their coloration started to become more red as opposed to yellow. So they started to get more orange or red pigments, and it was replacing a pigment that's found in our native berries. And so that's just a really cool observation. And now they're starting to study even more and find that this color change may have some impact in the way that birds select mates. And so this is just a reason why whenever possible, we want to obviously choose to not plant invasive or non-native plants, but also, if possible, remove them where we're able to. So then talking about interspersion, this is just the concept of having cover and not having cover and the distance between those cover sources. So if you're a small mammal out in the field on the left and there's a hawk flying overhead, they're going to be able to see you. You have nowhere to hide. But if you're a small mammal on the right, there are some of those patches of trees, some small areas where you can get to for cover. And so it's a lot more suitable habitat on the right there. It's also great places to hide from elements. So not even if you're not a prey species, but a predator species needs places to get out of storms and bad weather, things like that. Also the sun, these are great places to do that. Also some species with hibernation, they do need things like root balls to hibernate under. And so just having trees or having some broken up patches are a great way to make sure that those habitat areas are covered as well. So here's another example. Imagine if there are donuts on a table. There's 12 donuts in the room, and then 6 are on a table and 6 are hidden in different places around the room. The ones that are going to last the longest or maybe make it through the whole day are going to be those ones that are hidden, because people are probably going to go straight for the ones that are in view in plain view. And so this is kind of to start thinking about, if all of the resources are used up early in the season, then they don't have anything to get them through the winter, which is a problem for wildlife. And so they just having more resources scattered about in different places, and not just the ones that are all together congregated, is going to be better for wildlife. So how do resource concerns for wildlife fit in with farming? When we talk about farmland wildlife, we have to look at the landscape. If you're doing something like writing a conservation plan, start thinking about where wildlife habitat fits in the cropping system. We don't need to specifically set aside land for habitat, but instead look at where we can incorporate habitat into the system that already exists. Where can our habitat and cropping work together? Habitat doesn't need to take over a plan or be the primary goal of a plan, but just kind of being creative and thinking where it can fit in. Maybe where there's some unused or unsuitable portions that might be better utilized as habitat. And so in this picture, we can see a variety of practices. There's some windbreaks throughout there. There's a forested riparian buffer. There might be wetland area, I don't know, in some of those forested areas. Filter strips with grass, grass along waterways. So these are all typical practices that you see in a cropland system a lot of times, but they're beneficial to wildlife as well. So it doesn't have to be anything revolutionary when we're talking about wildlife habitat. It can be things that are already being done, but just thinking about the benefit to wildlife as well. So there are, sometimes we see NRCS programs used to establish wildlife habitat in something like a buffer situation, but can be used in different situations as well, like an upland grass situation, or areas that don't even have any water. A lot of these practices can be incorporated right into a existing crop system. Things like a forested riparian buffer or filter strips. Those are really beneficial to wildlife and are small commitments that typically don't take up huge portions of land that's good for planting crops. Obviously, farmers want to farm as much as they can because that's where they make a profit. So it's really about looking at things a little differently and seeing where these habitat benefits can fit into the whole system and kind of think of utilizing all the space for good in some way, whether that be for habitat or for planting. So these are the practices that we really look at for wildlife benefits, and they're also affecting other things. So when we're planning crop rotation, we're probably already doing that for soil erosion or soil health. And the same thing with leaving crop residues. There's also help with nutrient management and protecting water quality. So we're probably already thinking about those for that reason. Probably already discussing them with farmers or they're already doing it. And so wildlife fits right in there because it's not new or different, but it fits right into the practices that they're already doing and things that they're already thinking about. Know that these practices are good for a lot of things. So if we tweak them just a little bit, can we make them work for wildlife as well? Can we add a practice that's good for water quality, but also good for wildlife? Things like extending cover crop or delaying mowing or making the field just a tiny bit smaller to increase habitat. These things will help increase the benefit overall to wildlife habitat. So to wrap it up, going back to the goals at the beginning of this, what we were going to cover, we wanted to understand why we have to consider fish and wildlife. That's because it's a public resource and the state does regulate it. And we're required by law to not cause detriment to those public resources. Then to understand the resource concerns that are important to wildlife, mainly in this area, as I said many times, food and cover across the landscape and throughout the year is important. That we're not just thinking about one season. And then to begin to look at the agricultural landscape as an interaction of many systems that could complement each other and serve multiple purposes. So we went over a bunch of conservation practices that could be used in a conservation plan, and just to start to think of what small changes can be done to increase wildlife habitat and diversity that also work within the farm system. And so with that, I can take any questions that anyone might have.
Any questions?
Katie, there was a question. I don't know if you addressed this while you were talking or not about whether or not, I think it was about the cedar waxwings consuming the invasives. Is altering the color ultimately bad for their health also?
There hasn't been any research to show that it's bad for their health, but it may affect populations down the line if mating becomes unsuccessful because of this coloration change.
Great.
Yeah, well, I think that's all I have. Thank you guys for having me.
There's
Sure,
one more
thank you,
question that
Katie.
just popped up, actually, Katie, really quickly. Are there
Okay.
resources to refer to on pesticide applications on helping farmers make it more efficient or minimize harm?
Yeah, so there's not to, only talk about extension, but within extension we do have a whole pest ed team, and then also on our forestry and wildlife extension we have if we're talking about invasive plants, we have recommendations for pesticides for those specifically. So I would definitely take a look at the extension website. That's where I always go to for any pest ed resources.
Great, thank you.
Mm-hmm.
All right. Thank you, Katie, for your presentation. At this point, I think we're pretty well wrapped up with the end or with virtual day 2 here. So we'll let you go here in a moment. I wanted to let everybody know that the list of the list of items will be emailed out to you by Shannon Wenger of PACD. She'll be sending that out, like I said, via email, but I'm going to post it here if
That's the packing list, right?
Yeah, the packing list. Items to bring, basic 2023. I can get it out of my email and post it into the chat, and that way you'll have it. Here we go. Nope, it's not letting me do that again. Why? Ah, crap.
The internet is so friendly.
It sure is. It sure is. Wait, hold on. Maybe I'm.
It is coming to you, though.
It is.
You can
Maybe just
start
not immediately.
scrounging around for materials.
Okay, so there it's allowing me to do that. Hold on.
Sure.
That worked.
Oh, Caitlin says the email has been sent, so it sounds like maybe they just got it.
Okay. All right. Well, look for it in your inbox then.
Very
Reach
good.
out to someone if you don't receive it or if you don't find it in your inbox. Clinometer or
The
Abney level?
clinometer and Abney level. So if you have access to a clinometer in your office, if you can dig around and find one, bring one. We generally have some extras floating around. I think if we ask nicely, Jen Weld might even have a box of them she could bring along that we could borrow for the week, that we could get a couple loaners out so that you can learn how to use the tool and why you might actually want to talk your boss into buying you one so that you can use it in the field. The Abney level is just a type of hand level. Thank you, Jen. Is a type of hand level that has like a clinometer attached to it. So if that's the kind of hand level you have, you don't need a separate clinometer. But if you have a hand, just a standard hand level, like Stadia level, then, and you might want to bring a clinometer along as well. So, but I think we're in good shape.
Yeah, it looks that way. So at this point, we'll adjourn for the day, I think, and we will see all of you on August 28th at the Union County Government Building in Lewisburg at the not so ungodly hour of 9:30.
Yeah,
So
that's not
until
too
then,
bad.
Yeah, that's not too bad.
I think that the room block did include Sunday night if for some reason you decide you want to come in early. Lewisburg's not a bad area as you're thinking about dinner options. There's a couple of very popular breweries in that area and like a huge antiques mall up there. So if you need evening activities to plan, just know there's plenty to do.
All right.
See you guys in
Well,
Lewisburg.
Yep. See y'all.